Hello and welcome to this course on API development. Nearly all of us have interacted with an API before, even if we don't know it. If you've checked the weather on your phone or if you've ordered food online, then you relied on an API to give you access to another app's functionality or to retrieve information for you. In fact, most of today's web applications rely on APIs to work. An API, or Application Programming Interface, is a gateway to back-end data. APIs allow different apps and services to exchange information or allow access to functionality. And, as the use of mobile and other technologies increases, so too does the demand for APIs. This means that learning how to create and use APIs may be invaluable to you in your developer journey. And in this course, you'll learn about the tools and resources available to you to create and use APIs. To start off, you'll learn more about how APIs are used in the real world. Then, you'll have an opportunity to reflect on what you hope to learn, the course syllabus, and how to be successful in this course. After this, there's a short refresher on how HTTP and HTTPS work, including HTTP methods, requests, responses, and status codes, before moving on to REST APIs. You will learn how to set up Visual Studio Code and configure it with all the necessary extensions, and you'll also learn how to use a packaging tool like pipenv. When it comes to REST APIs, you will learn about their key characteristics, benefits, states and resource types, as well as the API request lifecycle. You'll also learn about the principles of authentication in a REST API and what the difference is between authentication and authorization. And you'll have an opportunity to create routes with the correct naming conventions when you create your own API and organize an API project. In the second week, you will learn how to install and set up Django REST Framework, or DRF. Following this, you'll also learn how to use function and class-based views to create API endpoints efficiently. You'll enrich your knowledge of serializers and gain insight into how to convert and validate your data. And you'll learn how to map user input to database models using Deserialization, as well as how to use throttling and caching to optimize and protect your API. In the third week, you will learn how to control access to your APIs and put systems in place to ensure you maintain their health. Lastly, you'll have an opportunity to complete the graded assessment, which is the Little Lemon Restaurant API project. And you'll get an opportunity to provide feedback on your classmates' projects as well, since this is a peer-reviewed assignment. If you've encountered new technical words in this video, don't worry if you don't fully understand them now. Everything you need will be covered during your learning, with each lesson made up of video content, readings, and quizzes. There are many videos in the course that will gradually guide you toward your goal of becoming a developer. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings and putting your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And remember, you're not alone in considering a career as a developer, which is why you'll also work with course discussion prompts that help you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and grow a network of contacts in the development world. To be successful in this course, it is helpful to commit to a regular and disciplined approach to learning. Although it is an online, self-paced course, you need to be serious about your studies and, if possible, map out a study schedule with dates and times that you can devote to attending the course. In summary, this course provides you with a complete introduction to API development and will set you on your way toward professional certification and a career in API development. Be sure to also check out the other courses in this learning path. Looking forward to working with you on your learning journey.
Designing an API is pretty much an art form in itself. There's a lot of craft and thoughtfulness in how we design things. I'm Selena, a software engineer at Meta working on Instagram Reels. I first got into software engineering, I think around the time when I was in middle school. I really fell in love with the process of web development and web design, which I actually learned just by myself out of curiosity. And so I would dissect websites and see how they, were functioning under the hood. I would follow tutorials by myself. And I really fell in love with this process of creating something tangible out of something seemingly abstract, like an idea or, like blobs of and lines of code in this case. So APIs are essentially the bread and butter of end-to-end full stack development. And I say bread and butter just because they're so crucial in terms of describing how software components interact with each other. So whenever you pull up your Instagram app, you are interacting with APIs all over the place. So there's a specific set of APIs that renders things like stories and photos and videos in your home feed. There's another API that does the same thing, but on your Explore page. And there's another API that registers things like double taps on a post as likes on the back end, and that tells your device to render that little heart icon in the red color. You can think of APIs as essentially an intermediary between an end user and a backend service. So say, like you can describe an API as a bank teller and the data the backend services host as the money in the bank. When you are a customer wanting to withdraw or deposit money from the bank, you're not necessarily interacting with the money directly. Instead, you go to a bank teller, in this case an API, which handles things like communications between the end user and the backend services, and also tells you how much money or like data you're able to access. So APIs at Meta are designed with a specific purpose in mind. So say the goal is to design an API for a user-facing product or feature. Typically, we have a designer that kind of creates the mocks, and we work with a product designer that essentially provides information on here are the high-level objectives of what this end product or service could look like. And then typically, the actual API design is a handshake agreement between several engineers. Typically, backend and front engineers agree on the API structure. And they also agree on things like what the request structure could look like and what the response could look like as well. So in thinking about designing an API, I think it's really important to consider who your end user is. Another thing to consider is also who are the people who are going to be accessing the data and also your API and services. So you want to make sure that you add a layer of security in the form of credentials to your request in order to preserve that integrity as well. My advice for aspiring developers is come at API design with an open mind. Remember that it's going to be a collaborative process between several engineers and potentially also product managers and designers, folks who are going to be really invested in the outcome of the API in the form of a product or an app or a service even. When you're building an API, you really have to think about components as part of a larger piece. And there is kind of like beauty and, like having an output that is reflective of things that you see in an application in the real world. And so just have fun with it, brainstorm with engineers, and get a sense of like what the target architecture for an API could be. So I hope that you have a better sense of what APIs are and how they fit in the software development lifecycle. I know that you have a lot of work ahead of you, but keep chugging at it just because it's so worth it to know how all these different components interact with each other.
By now, you know that HTTP stands for Hypertext Transfer Protocol, and that it's one of the most widely used communication protocols for transferring data across the internet. Let's briefly refresh your memory of HTTP and HTTPS before diving into more complex topics. In this video, you will learn about how HTTP and HTTPS work, HTTP methods, HTTP requests and responses, and finally, HTTP status codes. When you browse web pages, view images, or submit a form, your data is transmitted using HTTP or a secured version of it, which is called HTTPS. But how does that transmission work for HTTP and HTTPS respectively? Communicating over HTTP requires at least two parts: the client, who requests some information, and the server who responds to this request and serves the content. HTTPS is the secured version of HTTP, which makes it better suited to instances where security is a concern. But let's find out how this works. With HTTPS, the client's computer encrypts data before it starts its journey to the server. The server then decrypts this client-side data and processes it. But the web server also encrypts the response data and sends the encrypted content back to your browser. Your browser then decrypts the response and displays it. Since the content is encrypted, it is more secure and very difficult to steal or retrieve information from it. For submitting sensitive data, like credit card information, it is always preferable to use HTTPS to make sure the data is secure. Now, let's move on to some common HTTP methods. HTTP methods are also called HTTP verbs. There are 5 methods commonly used when accessing content over HTTP. They are GET, which retrieves a resource; POST, used to send data to the server and then create a record; PUT, which updates the whole resource; PATCH, which you use to partially update a resource; and DELETE, which deletes a resource. Next are HTTP requests, which contain different types of information that a user's browser sends as encoded data. A typical HTTP request includes the following: HTTP version type, for example 1.1 or 2.0, URL or path, HTTP method, HTTP request headers, and an optional HTTP body. But what are the HTTP request headers and body again? Well, when you submit a form, like your username and password to sign into a website, that data is passed to the web server as the HTTP body as either a raw JSON string or a form URL encoded string. HTTP headers, on the other hand, are a core part of every HTTP request and may contain extra information that helps the server make some decisions on how to present the content. Examples of HTTP request headers are cookies, user agents, and referrers. After an HTTP request comes the HTTP response, which consists of information that the browser uses to properly display the content in the response body. The response contains the resource that was requested, and it also contains information like the length of the content type, and headers like cookies. It also contains e-tags, the time when the content was last modified, and finally, the response also contains some special numerical codes called HTTP status codes. You've surely seen these HTTP status codes, but you might not have known what they are for. Well, they are not really messages addressed to you, the user. They actually provide extra information to your browser about the resource. For example, if everything is okay, the server sends 200. You will not be aware of this because it doesn't even display in your browser. Or, if the requested content can't be found, the server responds with the 404 error code, which usually displays in the browser because there is nothing else to show. Here is a range of error codes and their meanings. 100 to 199 are used for informational messages. The codes from 200 to 299 are successful responses. 300 to 399 provides redirection information. 400 to 499 are client error responses, and 500 to 599 are server error codes. Server errors are usually raised when the server-side code lacks proper error checks in the code, configuration mismatch, incorrect package dependencies, and so on. The client-side errors usually occur when the client makes a bad API request with insufficient information in the request body, or when the client requests a resource that is not present on the server. But take note that sometimes the same status codes can convey different messages in different contexts. For example, a 200 status code for a GET request means the content was found. The same 200 code for a PUT request means that the data transmission and update process was successful. Similarly, for a DELETE request, this 200 status code means that the resource was successfully deleted. Some of the most used status codes are 200 and 201, 303 and 304, 400, 401, 403 and 404, as well as 500. You will learn more about what these status codes mean as you move through the course. And that brings you to the end of this HTTP recap video that refreshed your memory about HTTPS, HTTP methods, requests, responses, and status codes. These are the fundamental concepts that you will use to develop sustainable and manageable APIs. Now that you've had a refresher on HTTP and HTTPS, you are ready to learn about REST APIs. But first, you need to know what is REST. In other words, what makes the APIs RESTful? An API, or Application Programming Interface, is a gateway to back-end data. It allows you to easily access and modify this data. And REST is an architectural style for designing APIs for your project. It is hugely popular among developers because it's much easier to develop and implement than other architectural styles. What works in your favor is that the learning curve isn't steep and you can create production-ready APIs in a short time. But let's not jump too far ahead. You're not quite creating APIs yet. Rather, you are first learning about the basics of REST APIs. REST APIs provide an easy way for you to communicate with the server and access the data that powers your application. But an API is only RESTful if it complies with certain constraints. Let's examine them. It must have client-server architecture, a REST API is always stateless, and it should be cacheable. It should be layered, have a uniform interface, and it might also include code on demand, but this is optional. Let's explore each in more detail. The API should use client-server architecture. There should be a server that is serving the resources, and there should be a client who consumes them. A REST API is stateless. This means that the server does not contain any state of the API client who is making the call, so it cannot identify who is making the request or what their previously requested data was without proper user information. In fact, the state is only saved on the client machine, not on the server, and this influences what you should include in your API's endpoints or URL paths, but more on this later. The API should also be cacheable. This means that responses can be saved by a web browser or a server or any system. This caching process can help to reduce the server load by using the API result from the cache, instead of making an actual request to the server every time. Layered means that the entire system architecture can be split or decoupled into multiple layers, and you should be able to add or remove a layer at any time. The following diagram will make this layering more understandable. Layers of a RESTful API system could include a firewall, load balancer, a web server, and a database. Let's move on to the constraint of having a uniform interface. This may sound a little confusing at this point, but it means that the system should offer a uniform communication system to access the resources. For example, there should be unique URLs for each resource. There should also be a unified way to modify or proceed further with a resource from the API result or representation in a standard XML or JSON format. Lastly, code on demand means that the API may deliver some business logic or code that the client can run to further improve the response result. To understand this code on demand feature, consider the following script tag that loads some JavaScript code from an API endpoint of the Little Lemon restaurant. Once loaded, this script can display any special menu items for that day. For now, these 6 constraints are just theoretical. Do not let them confuse you. Once you start developing your APIs, these terms will become clear to you. Next, let's focus on resources. Resources are a core part of every REST API, so it's important for you to become familiar with how APIs present resources. Say the Little Lemon restaurant has a mobile app, which can be used by customers and managers. Managers can use the app to get information about orders and customers, while the customers use this app to browse the menu and place orders. To support this, the app uses different APIs to fetch data from the server, and in each case, the resource type will be different. Let's explore a few examples. If a manager wants to see all orders, the app makes a call to the API little.lemon/orders and displays the result. The resource type in this case is a list of order objects. If a manager wants to view more specific information about a particular order, say the order with the ID 16, the app makes a call to the API little.lemon/orders/16. The resource type is the order object. To see who placed the order, the app makes an API call with an extra filter /customer. This retrieves all the details about the customer of that order. The resource type in this case is the customer object. Say the manager wants to look at what the menu items of order number 16 were. The app makes an API call that replaces /customer with /menu items. Only the menu items of order 16 will show in the result. And this time, the resource type is the menu item object. Now, on the other hand, if the customer wants to browse the menu, the app uses another API, little.lemon/menu items. And although the resource type will also be the menu items object, the return will be all available menu items of the restaurant. But sometimes the resource type is the same, although the result can be filtered to be more specific. Let's explore a final API to unpack this. This time, the customer wants to browse food items from a specific category, say appetizers. The app will add category appetizers. Notice that the endpoint is the same as the previous API, but it filters the output to only appetizers. For both cases, however, the resource is still menu item object. Now that you've explored a few examples of API resources, let's revisit the REST API constraint of statelessness. You need to keep in mind that the server always represents only what you ask for. It does not remember anything of what happened before. For instance, if the manager retrieves the information about order 16 and then wants to look at the menu items of order 16, you cannot just send a follow-up HTTP request to the endpoint /menu items, because this API will return all menu items and not just the menu items of order 16. The server does not remember that your earlier call was for a specific order. If you want to get the menu items for a specific order number, you need to explicitly supply that order number to the server as orders/16/menu items. In simple terms, this is what stateless means. The server cannot recognize the client automatically. API calls must include more information about the user, but you will learn more about this later in the course. In this video, you have learned how to create REST APIs by following some key constraints. You also learned about the core parts of REST APIs, like the resource types. These conventions will help you build APIs that are easy to use and maintain, but there is a lot more to learn on how to optimize your APIs. For instance, using the correct naming convention. But more on this in an upcoming video. By now, you know the importance of API endpoints and how they determine precisely what data the server will send to your app. But a well-designed endpoint also conveys valuable information about its purpose, which is helpful for developers and the project itself in the long run. Your REST API's Uniform Resource Identifier, or URI, is one of the first things that users will notice when a page loads. It is also called an endpoint or URL path. First impressions always make a big difference, and that is why naming conventions for APIs are important. This video will help you name your API endpoints for maximum clarity and impact. Let's get started. Say the Little Lemon restaurant menu app needs APIs to display all their orders. A suitable API endpoint is /orders spelled with a lowercase o and not orders spelled with an uppercase O. So, your API endpoint should always use lowercase letters and hyphens to separate multiple words. Using underscores or snake case, title case, or camel case to separate words is not optimal because it makes the names difficult to read and understand. There is an exception to the camel case rule, though. If your API accepts a variable, for example a user ID or order ID, you should always represent them in camel case and wrap them in curly braces. For example, if you want to create an API for a specific order, it should be /orders/open curly brace order ID with a capital I close curly brace. By adding /menu-items to the API endpoint, you can fetch the menu items for a specific order. Or you can fetch orders of a specific customer by changing the ID to customer ID wrapped in curly braces and adding /orders. Notice that the API endpoints contain two different variables, order ID and customer ID, and they are both denoted by wrapping them in curly braces and writing ID with a capital I. Also, always try to use clear, concise, and meaningful words in your API names to to make them easy to read right away. Next up, the use of forward slashes. If your project has related objects, you should use forward slashes in your API URIs to indicate their hierarchical relationship. An example of such a hierarchy is a customer can have orders with order items in a restaurant API project. Another example is a library can have books with authors. So to get the author of a particular book, you can use the API endpoint library/books/ and then book ID wrapped in curly braces, and finally /author. Or to get all books written by a particular author, you can use an ID for the author instead and add /books. Notice how the relationships between the customers and orders, the books, and the author are all indicated with the / in these API URIs. Another naming convention is that your API should always use a noun to indicate the resources it is dealing with. An API that returns a collection of books or a book should use the nouns books or books and book ID wrapped in curly braces. Similarly, to get the price of a book, you should use the nouns books, book ID, price. API endpoints with verbs like get all books or get user, user ID are examples of bad API names. That's because the resources in a REST API endpoint should be always represented with a noun and never with a verb. API endpoints such as users, user ID, delete, or orders, order ID, save are also wrong because they use HTTP requests as verbs to indicate the action the API performs. Remember, you should send an HTTP delete request to users, user ID to delete a user, and you should send an HTTP put or patch request to orders, order ID to update the order. Endpoints that use standard CRUD operation names such as create, read, update, or delete should be avoided for two reasons. The resources these endpoints represent should be nouns, and the appropriate HTTP requests like get, post, put, or delete should be used with those endpoints to perform the necessary manipulations. Something else to consider is whether file names should be used in APIs. The Restaurant API project can return API results as XML and JSON data. So the question is, can you design your endpoints as orders, order ID.json to get the JSON data, or perhaps orders, order ID.xml for XML data? No, you should never use a file name extension in your API. To solve this problem, you should accept the expected data format as a query string parameter. So, if you want the output in a JSON format, you can add $format $JSON to the API endpoint. And for XML, you can use $format $XML at the end. Similarly, to deliver a minified version or source version of a JavaScript file, you use API endpoints like /assets, /js, /jquery, /3.6.0, /min, or /assets, /js, /moment, /2.29.4, /original. But what if you need to filter a collection or perform a search? For instance, the Little Lemon restaurant has many items on its menu, but you are only interested in appetizers. To filter the results, you should always accept the data as a query string parameter. In a URL, everything you send after a question mark is a query string. Remember, the API endpoint menu items returns all menu items. But to only get the appetizers, you should pass the category name to the endpoint as category appetizer. Consequently, if you design APIs that can be filtered this way, other developers on your team will derive that to get a list of mains or desserts, they can change the endpoint to category main or category dessert. This is the beauty of a good and consistent API naming strategy. Another best practice is that when you share your API endpoints with your team or the public, you should never add a trailing slash to the end of the API endpoint. What this means is that API names that end with a /, like orders, order ID in curly braces, followed by a / is bad practice. So is sports, basketball, teams, followed by another / at the end. Simply end the API without the / at the end. So, if you want to become a fluent backend developer, you need to pay attention to your endpoints and make sure you use well-designed and user-friendly APIs. Let's recap the best practices discussed in this video. Use lowercase URI formatting. Indicate hierarchical relationships with a /. Use nouns for resource names. Avoid file name extensions. Furthermore, use query parameters for data types and don't use a trailing /. Finally, always follow a consistent naming strategy and standard API naming conventions. Well-chosen names for API endpoints can significantly improve an entire project by making it easier for other developers to use your APIs. And now you are well on your way to creating good API endpoint names. If you want to work quickly and efficiently as a developer, you need the right tools. For example, an intelligent code editor can help you develop more rapidly and become more competent. In this video, you will learn about a few command line and graphical tools that you can use to play around with your APIs. You will also explore a practical demonstration of how to test APIs in Insomnia. These tools are a cross-platform, so you can use them on Windows, macOS, and Linux. You will be using some of these tools, like Insomnia, throughout this course, so it's important to learn about them now. Let's get started. First is curl, a well-known tool for developers who want to make HTTP calls from the command line. It is available for all major operating systems, but it doesn't have a graphical tool. To use curl, simply open your PowerShell in Windows or the terminal in Linux or Mac OS, type curl and hit enter. Curl makes it easy to send HTTP GET requests. For example, simply add the API URI after curl. This command sends a HTTP GET request to Postman Echo, a service from Postman, to display the headers and request body sent to it. Pretty useful for testing API calls. It works slightly differently for a POST request. This time, add the request body using -d and the HTTP method name, which is POST, preceded by -x. The second tool is Postman, which has cross-platform desktop tools that make it easy to test and debug APIs. With an advanced graphical interface and a web version, Postman is a powerful tool for API development. With Postman, you spend less time fiddling with API details and more time building the perfect API. You can explore their website in the additional resources for more information and learning materials. Another important tool is the Insomnia REST client, a powerful REST API client used to store, organize, and execute REST API requests. Insomnia is free, cross-platform, and comes with a very user-friendly interface. You can download and install Insomnia for your operating system from the link provided in the additional resources at the end of this lesson. Note that there's only a desktop version for Insomnia. In the rest of this course, you will be using Insomnia to play and interact with the APIs you build. Let's examine how to use it. Insomnia is a great tool for playing with APIs. All requests in Insomnia will be saved in a request collection. To get started, click on the Create button in the top right corner and select Request Collection. Give it a name, like First Collection, and click on Create. Now you are inside an empty collection. To create your first API request, click on the plus icon on the left sidebar and select HTTP request. You can also do this by pressing Command+N on Mac OS or Control+N in Windows and Linux. You can double-click on the default request name New Request and change the name to something more personal, like First Request. At the top of the middle section, where it says Get, you can click and select the type of HTTP method your request is going to be. Leave it as Get for now. In the text box next to it, write your API URL https httpbin.org/get ? project =little lemon. httpbin.org is a free service that allows you to experiment with different types of HTTP methods. When you call one of these APIs, it prints back what you sent to it. Now hit the Send button on the right, and you will see that http-bin has returned the same query argument you sent to it, which, in your case, was project is equal to little lemon. This time, let's try making a new HTTP post request. To do this, click on the plus icon in the left sidebar and select HTTP request. Once the request is created, double-click on its name and give it a new name, such as second request. Now click on the HTTP method drop-down and select post, and this time add https httpbin.org/post in the URL field. You already know that a HTTP post request accepts arguments as form data or JSON data. With Insomnia, you can easily input data for a post request by clicking on the Body tab and selecting Form URL encoded or JSON. Here in this argument window, you can finally lay out all your arguments in an easy-to-use and organized manner. On the left, you can write the argument name, and on the right, the value. Write project in the argument field and little lemon as the value. Now click on the Send button to display the output. You can create as many requests as you want and come back later to play with them anytime. In this video, you learned about great tools such as curl, Postman, and Insomnia that you can use to create and test your APIs. Now you have the latest version of Python and Visual Studio Code with all the necessary extensions as well as pipenv. In this video, you'll learn how to set up a new Django project in a virtual environment using pipenv. You will also learn how to use your new virtual environment from the integrated terminal in VS Code. First, create a project directory called Little Lemon. Go to that project directory in your terminal window and type the command pipenv install Django. A lot of information will show while pipenv is setting up Django and creating the virtual environment for you. You can get started on your Django project by activating the virtual environment created by pipenv with the command pipenv shell. This will open a new shell session in the virtual environment for your project. Then, you can use Django admin to create a new Django project in this directory. To do so, apply the command Django-admin start project and little lemon dot. Now that you have a new Django project set up, it is time to create a new Django app for your API project. To create the app, use the command python manage.py start app little lemon API. Great, the Django app has been created with all the necessary migrations and configurations. Next, to run the Django server, type python manage.py run server. This will run the server on port number 8000 by default, and you can access the Django server at 127.0.0.1:8000 in your browser. For the rest of the course, this will be referred to as the localhost URL. If you want to run it with a different port number, you can do it by typing python manage.py run server 9000. Next, let's integrate the virtual environment in VS Code and apply commands from the integrated terminal. Open your project directory in VS Code and access the command palette from the View menu, or by pressing Ctrl, Shift and P on Windows or Command, Shift and P on Mac. Select Python, select Interpreter, and select the one that pipenv has created for you. You can find it with the name of your project directory. This is an important step, so be sure not to skip it. Now open the terminal in VS Code from the Terminal menu. You'll note that VS Code has activated the virtual environment created for your project by pipenv. Now you can run all commands in this terminal, like python manage.py run server, without any problem. You can also open as many terminal sessions as you want by clicking the plus icon and moving between them from this terminal tab. In this video, you learned how to create a Django project in the virtual environment using pipenv. You also learned how to run different commands from the integrated terminal inside VS Code. You are now all set to start developing APIs with Django. Creating a REST API is straightforward, but to make it robust, reliable, and perform well under loads, you need to spend time planning the architecture. And that's where this video comes in, because you will learn about REST's essential best practices that every API developer should know. First is KISS, which stands for Keep It Simple, Stupid. What this means is that you shouldn't try to perform too many tasks with one API. A single API should do one specific job and do it well. For example, for the Little Lemon project, the manager needs to update the item of the day, and you want to make this easier for him by creating a new API. One approach is to let the API determine what the previous item of the day was and to remove that status from the item. And then it has to randomly pick one item based on some criteria and set its status as the new item of the day. But this is asking the API to do too many things. And if you randomly pick an item, it might not actually be the most popular item that day, right? A better approach is to create only one API which updates the menu item. Now, when the manager updates the item of the day, a HTTP patch or put call is sent to the API to set the status of the previous item of the day to off. Say item 16 is the item of the day. The API for such a call would be menu-items/16 with a HTTP request body with a status set to off. The manager then manually selects a new item of the day, which makes another API call to update its status. A put or patch request is sent to menu-items/21 with a status parameter set to on in the HTTP request body. The new item of the day is now item 21. This way, there will be no chance of accidentally selecting the wrong menu item as the item of the day, and you're keeping your API endpoints simple and focused. The next best practice is that you should always provide a way to filter large result sets and rearrange them in ascending or descending order. Using pagination, you can deliver results in smaller chunks. For example, the API /menu items returns all available menu items at once, but a customer may want to see only the desserts or only the main courses. So, your API should be capable of filtering the results. Previously, you've learned that you can accept such filters as query string parameters to retrieve only appetizers or only mains. When building an API, it is always a good idea to enable it to send results in smaller chunks. This way, if the client application wants to display 20 menu items per page, it will not need to make an API call for thousands of items all at once. By using pagination, you can deliver API results in chunks, and clients can decide the page number and how many records they want per page. This API requests 4 items from page number 10 from a total page count of 16. Another good practice is versioning. Did you know that you may break a client's applications if you make changes to your API that might drastically change the response? It's better to be safe and use versioning for your apps. There are several factors to consider when deciding if an updated version is needed or if a modification to an existing representation is enough. In general, you should only support 2 versions of any given resource because maintaining multiple versions can be complex, error-prone, and costly. Next is caching. Previously, you learned that an API should be cacheable because it reduces the load on your database-related API calls. You should always implement caching and send relevant HTTP headers in your response. This will minimize the number of calls your client makes to your API. For example, if the mobile app makes a call to the endpoint menu items, you can cache the result the first time it runs, and then serve the cached result every time after that. This way, you can avoid putting a heavy load on your database every time you need to fetch menu items. You will only update the cache when a menu item is modified or added. For instance, if the appetizers menu is requested, but if there are no modifications to the menu items, all future calls to this endpoint can serve the same cached result without communicating with the database, and that saves a lot of computing power. Last is rate limiting and monitoring. If you want to prevent abuse of your APIs, try rate limiting. This limits the number of times someone can call your API in a period of time, like per minute, hour, or day. Some people even limit their APIs per 30 days. What about monitoring? You should monitor latency to make sure your clients are getting the best possible response time. If you are looking to get the most out of your API, it is essential to also monitor status codes. By keeping an eye on 400 to 499 and 500 to 599 codes, you can assure that your API runs smoothly and identify any potential problems early on. Monitoring network bandwidth is also important to know if someone is abusing your API. It's important to keep your API healthy, performant, and sustainable, and you can do so by following the guidelines and best practices outlined in this video. These included keeping things simple, filtering, ordering and pagination, versioning, as well as caching and rate limiting and monitoring. By keeping to these best practices and standard rules for creating sustainable APIs, you'll be designing great APIs in no time. By now, you should know the best practices for developing APIs, but there is another important aspect of APIs to consider: security. The core purpose of APIs is to make your data more accessible, not just for your apps and websites, but also for third-party clients. This way, your data becomes even more useful. But don't forget, because APIs are publicly available, they may pose a risk to your back-end services. Essentially, APIs give third-party apps access to your server and database. That is why it is crucial to secure APIs. This video covers how to keep your API safe and secure. And you'll learn about various security concepts and how to implement them in your own APIs. First up is SSL, or Secure Socket Layer. SSL encrypts your data and protects your data when it leaves your browser and the web server. When you set up the SSL certificates properly, your APIs can be served over HTTPS. The front-end and mobile application team that works on the Little Lemon project want to ensure that the data is transported securely. So, the API team has used SSL certificates from a reputed provider and installed them. Now all the API endpoints are secured and serve data over HTTPS instead of HTTP. That's why it's important to always check that the endpoint of your APIs starts with HTTPS instead of HTTP. Next is signed URLs. The Little Lemon project team wants to ensure that the API calls are coming to it from their mobile application and their website only. This is where signed URLs come in. Signed URLs give a client application limited access to a specific resource for a brief period of time. With a signed URL, every time an API is called, a particular piece of text called a signature is included with the URL. Server-side code can verify the signature and ensure that the call comes from an authentic source. But how do developers create these signatures? HMAC is a popular signing mechanism used by modern applications. It is easy to use and ensures the authenticity and integrity of the message. For example, some secret message encoded by a digest algorithm with a secret key, some secret key, creates this HMAC signature. Next, let's discuss authentication. All of us are familiar with usernames and password-based authentication. But sending a username and password to every API call is frustrating, and it's not secure. So, the Little Lemon team prefers using token-based authentication over HTTP-based authentication when securing its API, because basic authentication requires users to send their username and password in every call. With token-based authentication, the user sends their username and password to the sign-in URL and then receives a unique token in text form. After that, every API call will include this token as a HTTP header. The server-side code can check the token, extract the information hidden in it, and match it with an existing user. After this verification, the rest of the work is performed on behalf of that matching user. To create this token, you can use an ad hoc policy from the back-end framework you're using, or you can use something more industry standard like JSON Web Token or JWT. You will learn more about this later in the course. Next, you need to know that there are a couple of popular HTTP codes involved during the authentication process that you should be aware of. 401 means unauthorized. In this context, unauthorized means the username and password don't match, so the server cannot continue further. And then there is 403, which means forbidden. This is an interesting code, and it means that your credentials are valid and you have successfully identified yourself, but you don't have the authority to perform the action. Last is the cross-origin resource sharing or CORS policy and firewalls. When you design an API, you can accept calls from everywhere, or by configuring the CORS headers, you can only accept calls from some specific domains. And finally, another security measure that you can use is firewalls. If you want to ensure that only specific IP addresses can access your API, you can use a firewall application on your server. In this video, you have learned how to protect your APIs. Security is an important consideration when designing APIs, and you are now better positioned to protect your infrastructure and keep your user data safe and secure. The Little Lemon API provides a variety of APIs which allow you to view the details of an order. The output of these APIs may contain sensitive data, such as customers' delivery addresses, which should not be visible to the public. Only manager or delivery crew accounts should be able to access these APIs, and anyone else who tries to access them should be denied. This is where access control comes in handy in an API project. With access control, you can specify which users are allowed to access your API and what data they can see. That way, you can be sure that only the people who are supposed to manage your data can access it. In this video, you will learn about controlling access to your APIs. Roles and privileges are the building blocks of designing an access control system. A role is a collection of privileges, and a privilege is if you are allowed to do a particular task. If you consider the customer role in the restaurant project, it is made of the following privileges. Customers can browse menu items, add menu items to the cart, place orders, add food reviews, and browse their own orders. On the other hand, someone with a manager role will be able to do the following: add menu items, edit menu items, delete menu items, and browse all orders. Managers can also browse customer data, assign orders to the delivery crew, and browse transaction data. And the delivery crew will only be able to perform the following tasks: browse orders that are assigned to them, and update the status of an assigned order. There can be several roles like these in your project. For example, administrators, senior managers, HR accounts, and so on. Each role has a collection of carefully thought-out privileges. The more detailed and specific these privileges are, the better the access control system you can design for your API project. You have probably heard about the term authorization before. It is just another word for access control. Keep in mind that authentication and authorization are two different things. Authentication gets you in, and authorization allows you to do something after authentication or prevents you from doing it. In a real-life project, a user can perform multiple tasks from different roles. For example, the general manager of the Little Lemon restaurant should be able to perform everything an accountant, HR representative, and a normal manager can. So how can you deal with such issues while designing the API? You can create one role and assign all the essential privileges to it. So a manager will have all the privileges an accountant has. Then you can update or edit these privileges from time to time as needed. This makes it easy to keep your roles up to date and tailored to your needs. The second approach is that one user can have multiple roles. Task-specific roles make it easy to assign the right privileges to the right people. So, your accountants will only have access to accounting features, while your HR team will only have access to HR management features. And there's also a manager-specific role with relevant privileges. This way, you can assign all three roles to the general manager, and they will be able to perform every task an accountant, a HR, and a manager can do. And if you assign a new privilege to the accountant role, the general manager will automatically have that privilege added to their role. API design is not complete without effective access control. By taking the proper time to design and plan out your privileges and roles, you make life easier for developers and avoid costly debugging and refactoring down the road. A well-designed API access control system is an asset for the whole project. It saves time and money in the long run. Django is a robust Python framework for developing web applications and APIs. Since you are already familiar with Django, it's time to start your first API project. This is going to be a simple CRUD API project to keep track of books in a bookstore. Remember, CRUD stands for Create, Read, Update, and Delete. You will follow the standard API conventions you have learned, including HTTP methods and status codes. Hope you're excited. Let's get started. A bookstore contacted you because they need a website and mobile application to streamline the management of their books. From the website and mobile app, managers should be able to add and edit books quickly, and visitors should be able to browse the available book collection with no problem. So, for this project, you will develop APIs that support these features. First, to store the books in the database, you need a storage space or table, and you need a Django model to manipulate and define how the data will be stored in a table. Django models work like a bridge between the data and your business logic. For this project, you need to create a Django model with the following fields: title, which will be a char field with a max length of 255, author, which will have the same specs as the title field, price, which will be a decimal field with a maximum of 5 digits and 2 decimal places, and inventory, which is an optional positive small integer field to indicate if a book is in stock or not. Next, you need 2 API endpoints to allow users to browse a single book or the whole collection. Following the conventions for REST API, you decide to create the following endpoints: /API/books and /API/books and book ID, which is wrapped in curly braces. The first endpoint, API books, will deliver all the books in your database. This enables you to list books that are available to purchase, or you can list books that are out of stock. This is where the inventory field of your book model comes in. The second endpoint, which is API books and book ID, will show only a particular book. So, if someone requests a book that doesn't exist, they should get an error message with the appropriate status code of 404. Otherwise, for successful requests, the status code should be 200. However, although the results of a single book contain different fields such as the ID, title, author, and price, you are still accessing a single item, not an element in an array or a list. Therefore, the results should not be between square brackets because it is not an element in an array or list. Next, let's focus on how to create a new book by making a HTTP post request to the endpoint API books. In Insomnia, you can send a HTTP post request with essential data like in this screenshot. For a successful request, it should return the newly created book with a status code 201. If any required data is missing, for example the author's name, it should return an error message with HTTP status code 400. By now, you know how to create a Django model, how to create API endpoints, and how to create a new book with an API post request. But the results of an API request are usually delivered as JSON or XML data. Here is a quick tip for converting a single model to a JSON response. First, import the model-to-dict function from the django.forms.models module and the JSON response class from the django.http module. Now you can retrieve a single book record for the book ID and convert it to a JSON object. Next up, you will learn how to edit and delete a single book. To edit an existing book, you have to accept a HTTP put request to the second endpoint. To delete an existing book, you'll send a HTTP delete request. For deleting and editing, you can create a URL pattern for this endpoint in your Django project as API books open angle brace int :pk close angle brace. Previously, you learned that data is passed to the web server in the HTTP body as either a raw JSON string or a form URL encoded string, which is also called a payload. Here is an example JSON payload with a book's title and author data. But you need to parse this string to access these individual data elements. To do this, Use the query_dict class from the Django.http module to parse the request body to a Python dictionary. After this, you can access the individual elements of the HTTP request body from this dictionary. In this video, you unpacked the scope of your first API project for a simple book list. Let's recap the steps. First, you learned how to create a model to represent your database table, then how to create endpoints to request all the books and specific books. Next, you explored the responses to these requests and how to convert a model to a JSON response. You also explored how to create, edit, delete, and soft delete requests, and how to parse the HTTP body to access the data elements. When you plan before coding, you will always get a good result with minimum effort in debugging. Now that you have the concepts and quick tips, writing the actual working code should be straightforward. Upfront planning and organizing are crucial if you want a project to be maintainable. Putting in the initial work will save you effort down the road when you need to extend the project, add new features, or debug errors. In this video, you will learn how to organize your API project with multiple apps. You can use that knowledge throughout this course and in all your future projects to make them more organized and efficient. First, it's necessary to split a big app into multiple apps to make sure that all your goals are met. Splitting a big app into multiple apps means it's as decoupled as possible, with each app dealing with a particular set of relevant problems. Such splitting is an essential step to being productive with Django. Instead of creating an app that does everything, you should plan it properly, break down the overall aim into smaller aims, and then create multiple apps for each. Otherwise, what happens is that you add features to an app until you realize that it has become unmanageable. At that point, adding more features takes more time than usual, finding the cause of a bug becomes frustrating, and it takes so much time to deal with those issues that you eventually end up with a huge production block. Creating multiple apps for different aims can prevent such a block. But creating multiple apps also means that there are some other things that you have to pay attention to. Let's examine some of those now. You shouldn't use the global environment for your project dependencies. That's because not every project uses the same version of a package, and not every project needs all of them. Using the global environment will create conflicts for the packages and create more issues than solutions. Always use a virtual environment to avoid such conflicts. And that's exactly why you're using pipenv to isolate the dependencies in a virtual environment for your projects. By doing this, you avoid any potential conflicts and can ensure that your dependencies are exactly what you need for your project. Next, when you upgrade an API, it may break the existing app because the result of the new API might not be the same as the old one. For such upgrades, you should always use versioning and keep the old working API intact and launch the updated version so that the developers of the client app have enough time to update their apps to work properly with the new APIs. For the newer version, always create a separate app instead of adding everything in the old app, because it will be hard to manage over time. Another thing you should do is always save your packages and their version numbers in a separate requirements.txt file. This is to ensure your app does not break when you deploy it to the production, or when someone else picks up your project and starts working on it. If you are using pip, you can do it using the command pip3 freeze > requirements.txt. This is an example of a requirements.txt file, which contains a list of the packages with their version numbers used in your project. But if you're using pipenv, things are easier. It uses the piplock file to keep track of dependencies and complex interdependencies between the packages. So you don't need a requirements.txt file with pipenv. However, when setting up your project for the first time, pipenv can process your dependencies from the requirements.txt file. Next, when it comes to your resources, it's much better to have separate resource folders for each of your apps. That way, you can avoid conflicts and efficiently manage your files when required. Plus, keeping your app-specific static files inside the app itself, just like your templates, is a smart way to stay organized. Something else to consider is that instead of creating a combined settings file, you may split the relevant settings into separate files and include them all from the main settings. Not only does this process prevent a single long file that is hard to edit, it also helps you to manage your settings and easily find the ones you are looking for. You can use Django split settings for this purpose. The website link is in the additional resources at the end of this lesson. Last, instead of putting all the business logic into views, take them to the related models. Doing so will help you write manageable code and organize the necessary pieces in one place. Placing all the essential business logic in the models will make them more powerful, decoupled, and reusable, so you can write less code throughout your project. Let's briefly recap all the ways you can keep your project organized. You can split your app into multiple apps, use a virtual environment rather than a global environment for Python dependencies, create a new version of an app when upgrading an API, list your dependencies in a requirements file, have a separate resource folder for each app, split your settings into multiple settings files, and place business logic in models instead of in views. In this video, you learned how to keep your project more organized for better productivity, reusability, and easier deployments. You have also discovered some crucial points to keep your project manageable over time. Well done. As a developer, it can be fun to code something new and exciting, but if you make a mistake, you have to spend a lot of time trying to find and fix the issue. During this process, most of your time goes to finding what is causing the error and reproducing it in a controlled environment. Debugging allows you to find and fix errors in your code efficiently and helps you better understand how your program works. In this video, you will learn how to use the built-in debugger of Visual Studio Code and debug your code. Let's get to it. Open the terminal and activate the virtual environment for your project by typing pipenv shell. Now open the current project directory in VS Code and select the Python interpreter from the command palette, as shown in the previous video. Create a new Django app and open the project in VS Code. You can find the debugger icon on the left sidebar. Click on this icon and it will open a debug panel. When you open it for the first time, there will be a Create a launch.json file link at the top of this panel, along with the debugger icon. Click on this Create a launch file link, which will open a debug configuration list with many available options. Select Django from this list, and you are ready for debugging. There are two options in the Run menu: Start Debugging and Run Without Debugging. When you start the debugger, it will automatically activate your virtual environment in a terminal session and starts the web server. So, you don't need to manually start the web server anymore. Now, let's get familiar with a few important terms related to debugging. The first one is breakpoint. A breakpoint is a position where you intentionally want to pause the execution of your code. When the execution is paused, you can examine the variable's value up to that point. You can add or remove breakpoints by clicking on the red dot beside every line number in VS Code. The second one is watch. You can add variables to the watch list by clicking on the plus icon and examining their values whenever they change. Using the breakpoints and the watch list, you can continuously monitor how and when the values of those variables change. Now, let's move on to the debug toolbar. The debug toolbar will be visible when the code execution reaches a breakpoint and is paused. There are 6 buttons. Let's go through them. The first button is Continue or Pause, and it lets you execute code on the current line, and it continues until the next breakpoint is reached. Step Over lets you continue the execution to the next line and pause. If you use a function call and you need to go to that function and pause the code execution, you'll use the Step Into. And Step Out lets you go back to the line where it was called from inside a function. Restart means that you restart the debugging session, and Stop ends the debugging session and stops the web server. Now it's time to put the debugger to the test. Open the views.py file in your app and add this code. This code is supposed to present some even numbers to you. Create a route so that this function can be accessed by browsing the numbers endpoint. But when you visit the endpoint, nothing displays in the browser, and that is an indication that there might be an error in the code. Set a breakpoint on line number 9 and start the debugger. Now revisit that endpoint. The debugger didn't pause code execution on line number 9. This means that the value of the remainder was never set to 0, which is why line number 9 didn't execute. Next, let's add this remainder variable to your watch list by clicking the plus icon on the Watch tab. Set a new breakpoint on line number 8 and restart the debugging session. This time, the debugger paused the code execution. Step over a few more times and notice how the remainder's value increases by 0.5. Something is wrong here. The remainder should be either 0 or 1. So, let's examine line number 7 closely. Notice that I used the division operator instead of modulo. So, let's fix the code and replace the division operator with modulo. Now, remove all the breakpoints, restart the debugging session, and revisit the endpoint. And everything is working fine now. Notice how it displays only the even numbers. And that's how to debug your code using the built-in debugger in VS Code. In this video, you learned some important terms, and you learned how debugging works. You will most likely use this knowledge in all of your future API projects. Now that you know how to debug your APIs, you're ready to learn how to use some browser tools and extensions to help you develop APIs even faster. Let's talk about some useful tools in your browser's developer console. This is Chrome, but you can find a developer console and similar tools for every browser. Open the developer console. In the Chrome browser, you can do that by pressing Ctrl and Shift and the I key in Windows and Linux, and Command and Option and I in Mac OS. The developer console is helpful when debugging the API calls made from JavaScript on your website. If you come to the Network tab, you will find many options, but you should focus on the fetch/XHR filter. Click on the Console tab and paste this single line of code to initiate a HTTP GET call to your API and press Enter. You can use any valid URL inside this fetch function to test this. Now go to the Network tab and note that the API call has been recorded. It shows menu items on the left side. Click on it, and then click on the Headers tab. It will include all the request-response headers involved in this call. The Preview tab displays the output. The Response tab does the same. But the Preview tab renders the output in a more formatted style, and the Response tab shows the raw output of your API call. The Initiator is a very handy tab. It shows the line in your JavaScript from where this API call was initiated. At the top of this developer console, just below the Network tab, is a checkbox called Disable Cache. If you want to avoid client-side caching and you expect a fresh output from your APIs, then you should keep it checked. All the API calls from your JavaScript will be recorded in this Network tab, and you can inspect one after another. You can also delete all these recorded calls by clicking on the Clear option next to this red button at any time. Let's visit an API endpoint in your browser. For example, this public API, https://restcountries.com/v3.1/all. It displays a list of countries, but the JSON output is not formatted and looks messy. You can install a JSON formatter extension available for all major browsers. Go to the Chrome extension store, search for the JSON formatter, and install any JSON formatter extension of your choice. They all work mostly the same. After installing and enabling a JSON formatter extension, revisit the REST countries API and note how the output is now nicely formatted. In this video, you learned about using the developer console that comes with your browser to gather helpful information about your API endpoints and help you debug them. Well done. You've reached the end of this module about RESTful API development. Let's take a few moments to review what you have learned. First, you learned about how APIs are used in the real world from Meta software engineer Selena Florentin. That was useful. Then, to lay the foundation for the rest of the course, you had a quick summary of what HTTP and HTTPS are. In other words, all the basics. Like how HTTP communication requires a client requesting information and a server that responds to the request and serves the content, and that HTTPS is better than HTTP because data is encrypted on the client and server side. You also got a refresher about HTTP methods, like put, which you use to update a whole resource. And you were reminded of what HTTP requests and responses are, as well as the most commonly used status codes. Following this, you learned about RESTfulness, naming conventions, and essential tools for API development. First, you learned that REST is an architectural style for designing APIs for a project, and that you can only say that an API is RESTful if specific constraints are met. For example, REST APIs are always stateless. This means that the server cannot identify who is making the request or what their previously requested data was without proper user information. After this, you learned why a consistent naming convention is so important when it comes to APIs. Remember, your endpoints have to communicate their purpose to help you and other developers who might work on your projects. And there are some technical requirements too, like that you should use the / to indicate hierarchical relationships, and use nouns for resource names, not verbs. Next, you learned about tools that you can use to develop and test APIs, like Insomnia, which is a powerful, free REST API client that has cross-platform versions and a very user-friendly interface. Then you got a chance for some hands-on learning when you completed an exercise about API development tools and how to set up your tools and environment. In the third lesson, you learned more about the principles of API development. This included REST best practices, security, authentication, authorization, and access control. Now those were important. Just one of those best practices is that you should only support 2 versions of any resource because maintaining multiple versions can be overly complicated, error-prone, and costly. You also learned that API security is crucial because they give third-party clients access to your databases. And one of the ways you can keep your APIs secure is to use a signed URL to limit access to a resource for a specific period of time. And you can use token-based authentication, so the client's applications don't have to send their username and password in every call. Next up was access control, which was all about setting roles and privileges for users to make sure only the right people have access to data. And in the last lesson of this module, you learned about everything you should do before and at the start of a project so you could create your own booklist API project that keeps track of books in a bookstore. As part of this lesson, you learned about the project itself, how to organize your own project, as well as about XML and JSON response types. When it comes to organizing your project, it's important to split a big Django app into multiple smaller apps to make it manageable and to make sure you achieve all of your aims. And when you upgrade an API, you should create a separate new app because a new API may break the existing app. Finally, in an ungraded lab, you practiced creating your first API. Well done. But don't forget, creating an API isn't enough. You also have to know how to debug it. And that's why you learned how to debug Python scripts from VS Code using the built-in debugging tools. The lesson ended with a video about API mocking and how it can help developers in rapid API development. Mocking API is a great way to imitate a real API endpoint. Developers can use these mock APIs to develop their applications because they provide a similar response. Later, they can switch to the production version of the APIs effortlessly when it is ready. Congratulations! You've now covered most of the basic API concepts, and you are ready to complete the quiz and review the additional resources for this module. In the next module, you'll learn about securing an API in Django REST framework. Django is a great framework for developing APIs, but there are always areas that can be improved to speed up development time. That's where Django REST Framework, or DRF, comes in. DRF is a toolkit built on top of the Django Web Framework. It comes with many helpful utility classes and objects that can help developers build robust APIs quickly. In this video, you will be introduced to the Django REST framework, and you will learn the benefits of using DRF over plain Django. Let's examine how using DRF can save you time during development. DRF is a Django utility app that bridges your regular Django app, the Django framework, and the Object Relational Mapping or ORM library, which communicates with the database. Although Django's built-in templating system is great for developing web applications, DRF provides more functionalities. Because when it comes to API development, you need to be able to deal with other data types, like JSON and XML, and this is where DRF comes in handy. You will frequently need to retrieve data from the database, process it, and then represent it to your clients as mainly JSON. This conversion process is called serialization, one of DRF's biggest benefits. With DRF, you don't have to worry about transforming your database models into a RESTful API. It takes care of that for you with its support for data conversion utility classes. Let's examine some benefits of using the Django REST framework. It's pretty straightforward to integrate DRF into your existing Django app. With just a few changes in the settings, you can have a fully functional Django app powered by DRF almost instantly. DRF comes with an API viewer that allows you to send different HTTP methods with data and evaluate the output without needing an external application like Insomnia. This API viewer has limited features, but it works when you want to quickly experiment with your APIs. DRF comes with its own request and response objects, which are wrappers of the regular Django HTTP response and HTTP request object, but offers more flexibility in processing data in and out. The status module has a list of human-readable HTTP status codes. When you use the status module from DRF, you don't need to send status codes like 404 or 200 with your responses. Instead, you can use a readable representation like status.http_200_OK or status.http_404_not_found. You can find a link to a list of all the status codes in the additional resources reading of this lesson. The Django REST framework's built-in view set classes make it quick and easy to create a functional CRUD. You can extend the workflow if you need to, but for basic data manipulation, the view set from the Django REST framework works really well. You will have the full support for all the necessary HTTP methods out of the box. The DRF package comes with a number of built-in serializers to help with data conversion between models. Serializers also support converting other non-ORM objects. This can be a great time saver, as serializers make it easy to convert complex data into native Python data types that can be quickly rendered into JSON, XML, or other content types. Serializers in DRF also provide a method called Deserialization, which converts request data and connects them back to the existing models. This deserialization process also validates the user input to ensure no data corruption. DRF also comes with great support for modern API authentication systems. Building an authentication layer is a complex process and usually takes time. But with DRF and some supporting packages, you can effortlessly develop an authentication system for your Django app. You can also enable social connection, where your users can authenticate and authorize themselves using an external provider like Facebook and then consume the APIs. In this video, you have learned about the Django REST framework, also called DRF, and some of its benefits to help you quickly develop your API projects. Now it's time to get hands-on with installing and setting up DRF. By now, you know that DRF is a great toolkit to help you write APIs quickly. In this video, you'll learn how to install and configure the Django REST framework, or DRF, in a Django project with minimal effort. Now, the question is, are you going to use pip or pipenv? If you are using just pip, you'll need to manage all the dependencies and keep track of those packages. You'll also need to set up the virtual environment and configure it to function correctly. However, using pipenv, which works on top of pip, makes everything easier with a lot of work going on behind the scenes. pipenv creates and manages the virtual environment so you don't have to manually configure so many things to make it work. In this video, you will set up a new Django project using pipenv, then install DRF using both pip and pipenv and configure it properly. Let's begin. Open the terminal and go to your project directory and apply the command pipenv install Django. Now apply the command pipenv shell to activate the virtual environment and you'll be ready to work. Let's create a Django project and app using the following commands in your terminal: Django-admin start project booklist dot and python manage.py start app booklist API. Now you can use pip or pipenv to install DRF using the following commands. Either type pip3 install Django REST framework or pipenv install Django REST framework. Next, you need to configure the DRF, which is relatively straightforward. Open the settings.py file in your project and find the installed app section where all the installed apps are listed. Add REST_framework at the end of this list, and you are done. DRF is now configured and ready to use. You also need to include the Booklist API app in this list. Now, let's create an API endpoint making a HTTP GET request to the localhost URL /books. Open the views.py file from your Booklist API app and add the following code to it. This is a simple endpoint that displays the message. DRF comes with an improved version of the default HTTP response class called response. You'll need to wrap the methods with the decorator at API_view open and closed parenthesis. This is so you can use the response class. This decorator will be discussed later in the course. For now, let's just keep it as it is. To map this method to an API endpoint, create a new file, urls.py, inside the Booklist API directory and write the following code in it to map the URL patterns. And, finally, you need to include the urls.py file in your project's main urls.py file. Open the urls.py file in the Booklist directory and import the include function from the same django.urls module. Let's link the newly created books endpoint under the API/path. Add the following to the URL pattern section. Now run the web server using python manage.py run server. And the books endpoint can be accessed as http://127.0.0.1:8000/API/books. And it's time to test this endpoint using Insomnia. Open Insomnia and create a new request with the HTTP GET method to the localhost URL /API/books. Now click the Send button. You'll notice that the text List of the books returned from the API. Nice. At this stage, you might be wondering if you can accept any HTTP methods. Let's test it. Let's make a post call to this book's endpoint. Open Insomnia and change the method from get to post and click the Send button. Note that DRF is not accepting a HTTP post call to this endpoint, and it's returning a message saying method post not allowed. This is happening because you didn't instruct DRF to accept any other HTTP methods than GET, which is the default one. If your API endpoints need to accept other HTTP methods like post, put, or delete, you need to define them in the API view decorator. Let's go back to the view file and edit the API view decorator function. Write the following after the decorator: square bracket, single quotation mark, post, single quotation mark, closing square bracket. Now send the post request again and check the output. DRF is now accepting HTTP post requests to this API endpoint. Similarly, you can add put and delete if your API endpoint deals with those HTTP methods. In this video, you learned how to set up and configure the Django REST framework in a Django project. You have also learned how to accept different types of HTTP requests to an API in DRF. Well done. At this point in the course, you've already used the API view decorator a few times. And of course, there are benefits to using it in your regular function-based views. It certainly makes a difference when it comes to API development in Django. Let's examine some of the benefits of the API view decorator a little closer now by using this decorator in your DRF apps. Open the views.py file from the booklist project you created in the previous video. Do you notice the API view decorator before the books function? To use this API view decorator, you must add @API_view open and closed brackets before the function definition. To use the API view decorator, import the API view function from the REST_framework.decorators module. You should also import the response class from the REST_framework.response module because it comes with benefits over Django's native HTTP response. The API view decorator allows you to use this response class from the DRF. One of the most significant benefits of using the API view decorator is that it turns your standard API output into a nice browsable API interface. But you must use the response class to get this view. Open the views.py file and change the book function. Remove the @API view decorator and replace the response with the HTTP response. And browse the books endpoint /API/books. The API output is there as plain text. Now put the @API decorator back and return the response instead of HTTP response. Then revisit the endpoint. Now you have a polished interface. This is the browsable API view coming from the DRF. Another great benefit of using this decorator is that you can specify which HTTP methods your function should support. Just pass all those HTTP method names as an array to the API view decorator function. So now the books endpoint supports HTTP post methods. Let's revisit the books endpoint. Did you notice the change? Now the post method is showing in the allowed method list. There was another change in this view after you passed the post in the @API view decorator function. A new content area is now showing at the bottom of the page from where you can pass a JSON object and make a post call to this endpoint. You can do this right from the browser without using any external tool like Postman or Insomnia. There are two blue buttons in the upper right corner labeled Options and Get. By clicking on the Options button, you can view helpful information about the current API endpoint, such as which renderer DRF used to display the API output, what types of data this API accepts, and so on. And clicking on the Get button refreshes the whole page. You can also display raw JSON output by selecting JSON from the drop-down beside this Get button. The @API view decorator also allows you to implement throttling or rate limiting, by which you can define how many times someone can access this API in a given period. You will learn more about throttling later in this course. The @API decorator also helps you to authenticate your endpoints so that only authenticated users can call these API endpoints. Isn't that neat? In this video, you learned how to convert the standard API output to something more useful, a browsable API interface, with the help of the API view decorator function in DRF. You also learned about the other benefits of using this decorator, like authenticated API endpoints and rate limiting. By now, you should know how to create function-based views. Function-based views are just the regular functions inside your views file. In this video, you will learn how to create class-based views and leverage the benefits of API views in DRF. Function-based and class-based views each come with their own advantages. Function-based views are easy to implement, offer better readability, it's easier to use decorators with them, and you can quickly write a once-off solution using function-based views. With class-based views, you don't need to write as much code, there's less code duplication, and you can extend the classes and add features at any time. Plus, you can write specific methods for each type of HTTP request. Let's get started so you can observe class-based views in action. Open the views.py file from the same booklist project you worked on before. You will create your first class-based view in this file. Class-based views help you to keep your code clean and less cluttered, and you can avoid writing extra code by reusing the common functionalities. To create a class-based view in a DRF project, you must extend the API view class. So let's import it first from the REST framework module. You also need to import the response class. Let's create a class called booklist that extends the API view class. When adding methods in a class name, you should name them the same as the HTTP verbs. For example, get and post. Now let's return a simple message from this method. It's time to map this class-based view in the booklist API apps urls.py file. Open the booklist API /urls.py file, remove the old mapping, and add this line to the URL patterns array to map the whole class as a view. You don't need to map each class method separately. Now you can visit the endpoint /API/books. This endpoint will not accept a HTTP post request because there is no post method in this booklist class. Let's add one. The post method also accepts 3 or 4 arguments, like the get method. Remember, you are using the browsable API view. This means you can test this post method right from your browser. Visit the books endpoint and scroll to the bottom where you can add request parameters in the content text box. For now, just click on the post button and test the output. Now come back to the get method. What if the API client wants to list the books by a specific author? How can you accept the query string parameter from the following request? /API/books author equals Hemingway. You can accept this query string parameters using the request argument. The author parameter can be accessed using request.get.get and then author inside quotation marks and a set of parentheses. Let's change the get method to display the author's name. If the author is passed to the URL, it shows only that author's book. Otherwise, it will show all books. Next, visit the URL /API/books author equals Hemingway and check the result. You can accept JSON or form URL encoded data elements in a post method using request.data.get, open and closed brackets. Now visit the books endpoint in the browser, scroll to the bottom, and in the content text box, add this JSON data. This is called a payload. Payload is a common term used for any JSON data or form URL encoded data that you send to an API, and modify the post method to return the title from the payload. Click on the post button and check the result. Now I will demonstrate how to accept the primary key in the methods of the class-based views. To do that, create a new class called book. This class will manipulate the single book item. This time, add a get method with an extra parameter, the primary key denoted as pk. Open the urls.py file and map this new book class to the URL patterns array. Now visit the endpoint /API/books/1. Note the ID of the book in the API result. The put method, however, is a little different. You must add the extra argument pk and you can access the request parameters using request.data.get open and closed parenthesis, just like the previously created post method. Visit the following URL and send a JSON payload. The URL is the local URL host and then API/books/1. Click the Put button and note the output. Like the API view decorator, you can use throttling and authentication policies. You will learn about these later in the course. In this video, you learned how to create class-based views and use them in your DRF projects. You also learned how to deal with different HTTP methods in these class-based views and how to accept the query string parameters and primary keys, or PK, inside the view methods. You can save a lot of time using smart debugging tools and utilities. And one such tool is the Django Debug toolbar, which is necessary for every Django developer's toolbelt. In this video, you will learn how to integrate this debug toolbar in your Django projects. You can install the Django debug toolbar with pip or pipenv. Open the project directory in a terminal window and activate the virtual environment with pipenv shell. Now install the Django debug toolbar using pipenv install Django debug toolbar. The next step is to add the debug toolbar in the installed app section. Open the settings.py file and add debug toolbar in the installed apps array. Now you need to add a special URL pattern to your project to map the debug toolbar. Next, include a middleware called debugtoolbar.middleware.debugtoolbar in the middleware section in the settings.py file. You can find this section just below the Installed Apps section. Finally, include the localhost IP address in a new section called Internal IPS. This section is not in the settings.py file by default, so you must create it. Excellent. Now you are done installing the Django debug toolbar. Let's visit any of the endpoints. For example, place /API/books at the end of the localhost URL. Now you should notice the debug toolbar on the right side of the screen. It contains information about your current project setup, the current requests, and the database queries. If the toolbar is open, you can hide it by clicking on the Hide link at the top of the debug toolbar. You can also enable and disable any sections of the debug toolbar using the checkboxes beside each of them. The Django debug toolbar has many sections. Let's explore some of the important ones. The Settings section displays all the settings you have in your settings.py file and other settings used throughout the project and the installed apps. If you want to override a setting, copy its name and value from here and then add it in the settings.py file with the new value. Let's move on to the Header section. This section includes all the header information sent to this request and those generated in the response. The SQL section is one of the most useful sections in the Django debug toolbar. It shows the list of SQL queries executed for this endpoint. This is the place where you often check for performance tuning and optimization. From here, you can easily detect if more than the required SQL queries are running and then take the necessary steps to fix them. The Static Files section displays all the static files loaded for current requests and those used by the installed apps. Developers usually do not serve static files from API requests. Still, you should know about this. The Caching section displays applications that use the cache. By now, you should know that caching helps to reduce the server load to a great extent. You will learn more about caching later in this course. The last section I want to highlight is profiling. This is unchecked by default, and you can enable it using the checkbox next to it. The profiling section displays the complete call stack. When you make a request, a file in your project intercepts the call. Then it invokes another function. That function calls another one, and it goes on like this. It then comes to your function or class-based views, and thereafter jumps to another file to generate the response and display it. So, the profiling section contains this full code execution flow. Please note that the Django debug toolbar will only be visible during development when you use the browsable API. It will not show when you are making the API call in the production view or when it returns data as the client apps are consuming the APIs. In this video, you learned about an important tool called Django Debug Toolbar, which can help you to debug and optimize your API project. You should now be able to include it in your project and use some important sections in the toolbar. Now that you are already familiar with the class-based views, this video will walk you through the steps to create a fully functional CRUD API project that can allow you to read from the database, display records, update and delete them with just a few lines of code. You already know how to create a Django project and install DRF with the virtual environment using pipenv. Let's do that. Create a new app called Little Lemon API and include this app in the settings.py file. Ensure you have included the REST framework app as well. Otherwise, DRF will not work. You need a database model first. Let's open the models.py file and add 3 fields: title, price, and inventory. Another thing you need for this project is a serializer object. By now, you know that serializers help to convert model instances into Python data types that can be displayed as JSON or XML. It also helps to convert a HTTP request body into Python data types and map them to a model instance. But you will learn more about the 3 different types of serializers later. For now, let's just create a simple model serializer. Open a new file inside the Little Lemon API app called serializers.py and add the following code. Don't worry about the details right now, but make sure that it has every field from the menu item model in the field section. Now open the Little Lemon API /views.py file. This is where you will write code for this project. This time, you are not going to write everything from scratch. Instead, you will take advantage of the generic view classes built into DRF. These classes have everything built into them for CRUD operations. Import the generics module from the Django REST framework, the menu item model, and the serializer you just created, menu item serializer. Now it's time for some DRF magic. Create a new menu items view class and extend the list create view class from the generics module. List create view can display records and accept post calls to create new records. To function correctly, a list create view needs 2 items: a query set that retrieves all the records using a model, and a serializer class to display and store the records properly. So, let's create these 2 items. You're almost done. It's time to map this class in the URL patterns. Create a new file called urls.py inside the Little Lemon API app and add the URL pattern that you learned earlier: views.menuitemview.as_view. Next, include this file in the main urls.py file of your project. Just add the following line inside the URLs pattern section: path, and then in parentheses type API/include. Add another set of parentheses and type littlelemonapi.urls and close the 2 sets of parentheses. That's it. It's time to test your code. Run the web server using python manage.py run server and visit the localhost URL /API/menu items. Okay, at this point you don't have any menu items, so none are included in the output. So, it's time to create records. Since you have extended list create API view, this menu items endpoint automatically supports HTTP post calls. Scroll down and you will notice a form to add menu items with a title, price, and inventory fields. Great, let's add some data and hit the post button. Now visit the menu items endpoint, and this time all your records are returned by this API. Next, let's display a single record using the endpoint menu items /item ID. For this, you need to create another class in your views.py file. Open the views.py file and create a new class called Single Menu Item View. This time, you will extend the generics.retrieveUpdate API view and the generics.destroy API view classes. The retrieveUpdate view class has everything to fetch a record, display it, and accept put calls to update them. And the destroy API view class has everything to accept delete calls and finally delete a record. And just like before, you need a query set and a serializer. You can copy those two lines from the menu item view class and paste them here, and map this new class in the Little Lemon API /urls.py file. Success! You're done. Now you can visit the localhost URL /API /menu items and /1 to display a single record. If you scroll down, you will notice a form that you can use to update this record, and there is also a delete button to delete this record. You can send HTTP GET, PUT, patch, and delete calls to this endpoint, which works without any issues. That's it. You have created a fully functional CRUD API project using DRF with just a few lines of code. Congratulations! You also learned to take advantage of the generic view classes from the Django REST framework to avoid writing everything from scratch. Data conversion is an essential process in API development, and the serializers in DRF make it easy. By now, you should know about serializers, but this video will explain how you can use them in your API projects. Let's recap the function of serializers. You can pull data from the database using Django models and then represent this data to your clients. You can also convert user-supplied data into models to store them safely in a database. And before storing this data, you can use serializers to ensure the integrity of the data and avoid data corruption. Serializers are the most popular feature in DRF. They are essential for converting objects and Django models into a more readable format, like JSON or XML. They can also parse the JSON data and map them onto an existing model. This is the opposite of serialization, and it is called deserialization. Serializers can also validate data during this deserialization process, ensuring that your data is clean and consistent. Now for a practical demonstration of serializers and how to use them effectively in your project. Creating a new file called serializers.py will help to put all of the serializer-specific code in one place. This will be located in the Django app directory. Let's quickly go to the menu item model in the models.py file. This model has 3 fields: title, price, and inventory. Before adding a serializer, let's create a method to fetch all menu items in your views.py. Name it menu_items and write the following code in it. If you visit the menu items endpoint, all menu items are displayed as JSON data. The DRF will automatically take care of converting a query set object and display every field of the menu items. If there is a sensitive field you don't want to expose to the public, you cannot hide it without the help of a serializer. Now open the serializers.py file in your Django application and write the following code. The serializer fields are similar to the fields in a model. You can add all the fields you want to display in the API result or hide them from here. Let's use this serializer in the views file. Add the following line. Note you are passing an argument called many equals true. This argument is essential when you are converting a list to JSON data. Now browse the same menu items and note how the result has changed. The price and inventory fields are not in this result anymore. To bring them in, you can add price and inventory fields to your serializer. Let's refresh this endpoint in the browser to test how the result has changed. Now I'm going to use this serializer for a single record. Create a new method and add the following code to it. Did you notice that I'm not using the many equals true argument this time? That's because it's not required to convert a single object. You can map this single item method in your application's urls.py field like this. Now browse the menu items endpoint and note the output. Make sure that you have records with this ID in your database before visiting this endpoint. What happens when you visit this endpoint with a non-existing ID? You will get server errors. but you can convert it to a friendly error message using the getObject or 404 method. Now let's change the single item method a little bit. And you are done. If you visit this endpoint with a non-existing ID, you will receive a JSON error message saying not found. In this video, you have learned how to use the Serializers in Django REST framework to quickly convert multiple or single database records to JSON data and save a lot of time by not doing everything manually. In a coming video, you'll learn how to make these serializers even easier by converting them to model serializers. In the previous video, you learned how to use serializers in DRF to convert query set with single or multiple records from the database to JSON. There is an easier way to do this using a special kind of serializer called model serializer. This time, you are going to learn how to write less code and easily convert Django model instances to a JSON object. Let's open the menu item model from the models.py file. There are three fields called title, price, and inventory. Now I open serializers.py in my Django app. This is where I wrote the serializer in the previous video. I will comment out everything and write a new menu item serializer class. Now open the menu items endpoint. Everything is working without any issues. You don't need to change any code in the views.py file. Let's visit the single item endpoint. Everything is working perfectly here too. Now back to the model serializer. If you want to change the name of a field, for example, inventory to stock, you can easily do that here. I'm going to remove the inventory field from the fields array and add a new line above the meta class so that the final code looks like this. Did you notice how I created a new field in this serializer but linked it to an existing field with the source argument? Remember to include this new field in the meta class, otherwise you will get an error. You can also use a calculated field in the serializers and model serializers. Let's introduce a new field called price after tax, which will be an extra 10% of the product price. Add a new method in the menu item serializer class like this. Then, import the decimal from the decimal module. Now, let's link this method as a new field in the serializer. Add the following line above the meta class and include it in the fields array. This is the final code. And when you revisit the endpoints, everything is working fine with the changes. In this video, you learned how to use model serializers in the Django REST framework to convert model instances quickly and easily to JSON. You have also learned how to change the name of a field in the output of an API and how to use calculated fields in a serializer. In a later video, I will demonstrate how to serialize relationships. In almost every Django project, you'll have related data in your database spread out across multiple tables. To establish these relationships in your project, you write models and connect them one by one. You're already familiar with DRF serializers and have worked with model serializers. But in this video, I'll demonstrate how to use a new type of serializer called a relationship serializer to convert related models to JSON and display them correctly. Let's go to the models.py file where you create a new category model and connect it to the menu item model. While creating the foreign key, you have to ensure that the category cannot be deleted before all the related menu items are deleted first. And this is done using on_delete equals models.protect. Make sure you created the migrations in your terminal and migrate them before proceeding further. Now you can visit the menu items endpoint. You'll notice that the category is not present in the API result because we did not add this category field to the menu item serializers fields list. So let's do that and revisit the menu items endpoint. Now we can see the category ID. But what if you want to do something special, like display the category name using the relationship serializer in DRF? Let's go back to the serializers.py file and import this new category model at the top. All the category names should be displayed, so you're going to add this line in the menu item serializer above the meta class. When you visit the menu items endpoint, it's clear that nothing has changed. Why is that? Because you didn't specify in the category model how to convert the category model to string. Let's go back to the models.py file and add this method for the string conversion. In this case, when you're converting a connected model to string, you also need to change your view files to load the related model in a single SQL call. This will make your API more efficient by not running a separate SQL query for every item to load the related data. Visit the menu items endpoint, and there's the category in the API result. Now let's use a separate serializer for the category to make it even more detailed. Open the serializer.py file. Add a new category serializer above the menu item serializer. And add this new category serializer in the menu item serializer as a category. Remove the previous category field above the meta class and add this line here. Now revisit the menu items endpoint and note how the category field is displayed with every menu item. This is how you create relationship serializers in DRF. In this video, you learned how to create relationship serializers in the Django REST framework and properly display all the related data. You also learned how to tweak the views file to load the related data more efficiently. Deserialization is the opposite process of serialization, and it happens when the client sends some data to your API endpoints and DRF maps that data to an existing model. This video will teach you how to deserialize and validate the request data in your API. Let's start with the Little Lemon project where you left off. Open the project in the VS Code editor and head to the Little Lemon API views.py file. Currently, both the menu items and the single item functions only accept the HTTP GET call. Go to the menu items function and add post method support by adding get and post in the API view decorator function. You must check the request type before processing the request. If it is a GET request, retrieve the records. Otherwise, create a new record and save it using the deserialization process. Now indent the current code inside an if-else block, one for the GET request and one for the POST request. To deserialize the request data, you have to pass it to a serializer, so let's do that with the menu item serializer. The request data must include all the essential field data. If any of this information is missing, you should raise an error so that the client can send the request again, correcting the payload. The data validator is built into the serializer, and it can be invoked using the isValid method. If everything is okay, the code execution will continue. You can access the validated data using the validated data property of the serializer, or you can save the record in the database by calling the save method of the serializer. To save the record, simply call the save method. Using the data attribute of the serializer, you can access the record after saving it. Please be aware that you cannot access this data attribute until the save method is called. If you need to access the data before calling the save method, you can use the validated data attribute. Now visit the menu items endpoint and scroll down to the content text area. You will make a post call with this JSON payload. Click the post button, but there is an error saying the category field is required. Why is that? Open the Little Lemon API serializers.py file and check the line where you included the category serializer. This category field should be read-only because it is only needed to display the category details in the GET call. To solve the problem, you have two options. One is to comment out this line, which will hide this field from the GET request, but you do not want that. So, let's rather go with the second option, which is marking this field as read-only. Now come back to the menu items endpoint and submit another post request with a JSON payload. Excellent. Everything is working fine this time. but the records are stored in the database with category equal to 1. So what if you want to save a menu item with a different category ID? To do this, open the serializers.py file and add this new category ID field above the meta class, and add a category underscore ID field to the fields list in the meta class. Now, if you revisit the menu items endpoint, notice that both the category and category ID fields are present. But something is off because the ID of the category is already present in the category details, and there is no need to display the category ID again. So the question is, how can you hide the category ID field from only the GET API calls? In other words, how do you make it a write-only field? Open the serializers.py file and add a write-only equals true argument to the category ID field. Then make a post with an optional category ID and revisit the menu items endpoint. Now there is only one category field. Great. You now know how to use deserialization in your DRF project. But here is a helpful tip. Instead of making one serializer do everything, you can create multiple serializers and use them separately in your GET and POST calls. In this video, you learned how to use deserialization to convert the HTTP request body into a model instance, validate it, and finally store it in the database. You also learned a helpful trick for hiding a specific field from GET requests, which can come in handy over time. By now, you know plenty about how to optimize APIs and retrieve, send, and convert data. But in the end, you need a way to display this data so that users can make sense of it. While JSON is the most popular data format for APIs these days, it's not the only format client applications use. Some of these clients prefer XML, and some of them may want the output in YAML. So, the more support you add for your API output, the more usable it becomes. Renderers are responsible for displaying the output of your APIs. Some of these renderers display the JSON content, some XML, and some are responsible for the HTML. Besides the built-in renderers, there are many third-party renderers available to use. Commonly used renderers are the built-in JSON renderer that displays JSON data, the browsable API renderer, which is another built-in renderer and shows the browsable API view. The XML renderer is a third-party renderer and displays XML data. Another third-party renderer is the YAML renderer, and it displays YAML data. Lastly, there is the JSONP renderer, also a commonly used third-party renderer that displays JSONP data. In this video, you will learn how to take advantage of some of these renderers in DRF. Renderers are everywhere in DRF, and you've been using them all along. It's just been happening behind the scenes. One of the most popular views, the browsable API view, is rendered using the browsable API renderer. In DRF, you can change the renderers anytime. You can use a particular one or multiple renderers, so that one from this list will respond to the API depending on the type of content requested. So, where can you set the type of content you want from the API? You do this by setting a header in the HTTP request, which is called accept. Type accept:/application/JSON. By default, DRF uses two renderers. One is the JSON renderer for JSON output, and the other one is called the browsable API renderer. Say you want to turn off the browsable API renderer and only want to include the JSON content every time. To do this, open the settings.py file and add a new section called REST_framework, if it's not already present there. DRF uses this setting to initialize the renderers. Add the following lines of code. Now comment out the browsable API renderer. Next, visit the menu items endpoint by adding /API/menu items to the end of the localhost URL. The output now comes in plain JSON because the browsable API interface does not work this time. Let's bring it back by removing that comment in the settings file. The browsable API view works only when the accept header is set to text/HTML. And this is the header that browsers send by default. But if this header is not set, DRF returns only the JSON output. You can test it further in Insomnia. Open Insomnia and create a new HTTP request to the endpoint /API/menu items. Click the Send button. Only the JSON output displays, right? It happened because you did not exclusively send an accept header, so DRF used the default renderer, the JSON renderer, and sent JSON data in the response. Now let's fix this. From the Header tab, add a new header called accept and set its value to text/HTML and send the request again. Is the response different this time? Yes. Insomnia is now using the browsable API interface instead of JSON. So far, you know how to use the JSON and browsable API renderer. Next, let's add support for a new content type, XML. You will be using a package called Django REST Framework XML. Open the terminal and make sure you are in the virtual environment by using the pipenv shell command. Install this package using pipenv install Django REST Framework -XML. Now let's go back to the settings.py file and add a line of code in the default renderer classes in the REST Framework section that is similar to the ones you added earlier. Type REST Framework xml.renderers.xml renderer. Move back to Insomnia, set the accept header to application/XML, and send the request again to the menu items endpoint. The output now comes in XML instead of JSON. In contrast, you will receive the JSON output if you send the accept header with the value application/JSON. Well done! Now you understand how to use different types of renderers in DRF. In this video, you learned that the renderers in DRF play a crucial role in displaying API output. You should now be able to turn off the browsable API renderer whenever you want and display JSON and XML content using the appropriate renderer. In no time at all, you have finished the second week of this course. Great job! Now it's time to review what you learned about using the Django REST framework to create APIs, serialize your database models, and convert, validate, and render data. In the first lesson, you were introduced to the Django REST framework, or DRF. As you now know, DRF is a toolkit built on top of the Django web framework, and you can create APIs with it much more efficiently. This is because it can retrieve data from the database, process it, and then represent it to your clients as JSON, XML, or other formats of data. Just some of the DRF benefits are that you have a built-in API viewer at your disposal, you can use human-readable HTTP status codes, and the built-in serializers help with data conversion. And what's more, the serializers can also perform deserialization, which you can use to convert user-supplied data into models to store them safely in a database. Next, you learned how to install and configure DRF so you could observe a working server. And you learned about the benefits of using pipenv over pip. When you use pip, you have to still manage all the dependencies and keep track of those packages. And you'd also have to set up and configure the virtual environment. But pipenv works on top of pip, and it does several things for you automatically, like manage the virtual environment. After learning about installing and configuring DRF, you learned more about the API view decorator and its benefits, like, for example, how adding API decorators in DRF can help you to quickly prototype, inspect, and test APIs because you can work directly in the browser. You also learned about different types of routers in DRF and how they are used to auto-configure the URLs from class-based views. This means that you don't need to create individual URL patterns for each class method. Following this, you learned how to create function and class-based views and link them to routes in DRF. And you learned about the advantages of class-based views, like how you don't have to write as much code, there's less code duplication, and you can extend the classes and add features at any time. And that's not all. You can also write specific methods for each type of HTTP request. You also learned how to integrate the Django debug toolbar in your project to debug your APIs. You explored important sections like the SQL section, which shows the list of SQL queries executed for this endpoint. This is the place where you often check for performance tuning and optimization. Next, you created a restaurant menu API project with DRF that can create, list, edit, delete, and select menu items. And at the end of the first lesson, you tested your new skills by converting your booklist API project to DRF. In Lesson 2, you learned about Django REST Framework Essentials. Here, you learned even more about serializers and explored a practical demonstration of serializers and how to use them in your project. After this, you learned about relationship serializers and how you can use them to display related data of connected models in the output of your API. Next, you learned more about deserialization techniques and how it helps you to validate the HTTP request body and map it to an existing model, whereafter you can save it to the database. Following this, you learned about the built-in renderer object in DRF and how to use it to display different types of content. Renderers are responsible for displaying the output of your APIs. Some of these renderers display JSON content, some XML, and some are responsible for the HTML. Besides the built-in renderers, there are many third-party renderers available to use. Finally, you completed an ungraded lab centered on a restaurant menu API in which you used serialization, validation, and deserialization to display API data in JSON and XML format, and you created HTML forms to add and modify menu items. Overall, after completing this week, you should be able to install and set up Django REST framework, use function and class-based views to create API endpoints efficiently, create a basic API using DRF, serialize database models using model serializers, convert and validate data using serialization, map user input to database models using deserialization, and use throttling and caching to optimize and protect your API. You should be proud of all the hard work you've done, and now you're ready to tackle the module quiz. Good luck. Almost all modern apps and websites provide users with a search function. This is one of the most basic ways users interact with the internet. But in order to make this possible for the Little Lemon website and app, you need to adjust your API endpoints. In this video, you will learn about implementing searching and filtering in your API. Remember the menu item endpoint you developed in the Little Lemon project? It displays all available menu items at once. When a client application makes a HTTP call to the menu items endpoint, it will display all items along with their categories. But what if a visitor only wants to view items from the appetizers category or only the main dishes, rather than everything at once? Perhaps a visitor prefers to view only items that are within a specific price range, such as $7 to $15. Similarly, a visitor may want to search for menu items containing the word pizza or drinks with the word mojito. And this is where the filtering feature comes in. Filtering is a process that allows the client applications to get a subset of the results from your API based on some criteria. You have two options when client applications want a subset of the result. For example, all the menu items from the appetizers or desserts category. First, you can do nothing and display all the items with their category names. The client application then processes this data and manages all kinds of filtering on its end. Or, as an API developer, you process those conditions in the server and deliver results matching those criteria. There are pros and cons to both approaches. Using the first approach, you need less time to develop your API, but it comes with a price. First, you have to pull all the records from the database every time. For hundreds of records, this might not be an issue, but when there are thousands of records, or 10,000 or even millions of records, then this is not sustainable. It will create a significant load on the server, and fetching 10,000 records from the database does not make any sense when you need only 10 or 20. The second approach will take some extra time to develop, but the benefits are huge. For example, You are putting less load on the server and reducing the development time for the client applications because all the filtering is done on the server side. Let's open VS Code and explore how to adapt your API endpoints for searching and filtering. You are going to filter the menu items by category name and price. Let's go to the menu items function in the views.py file. This is where we will implement the filtering. Client applications can pass a query string to the menu items endpoint with the query string $category $, and then the item they are searching for, such as main or ice cream. They can also filter menu items by price by adding $2 underscore price $, and 3 to the API endpoint, or they can use both criteria with an ampersand in between. Check the menu item model. The category model is linked inside the menu item, and it has a title field. You will use this field when you are filtering records. To filter the items, come back to the menu items function. You will now add parameters after the line where you fetched the items. Retrieve the category and price query parameters as follows. Category name equals request query params, get, and in between parenthesis and quotation marks add category. Do the same for the price. Now you should check if the API users supplied some value for these parameters. This can be done with a simple if-else block. To do this, add the following 2 lines before the serialization happens. If the category name is present, filter the items with this code, items.filter, open parenthesis, category. Now, very important, add 2 underscores, title equals category name, close parenthesis. This title field belongs to the category model and is linked to the menu item model. So, you need to use a double underscore between the model and the field to filter a linked model, like a category inside the menu item. For a regular field, like price, you use the field name like this. Start with items.filter and a set of parentheses again, but this time add price, 2 underscores, LTE equals to price in the parenthesis. So what is this LTE added after the price? This is a conditional operator or field lookup, and the price $LTE means price is less than or equal to a value. You can find a list of these field lookups in the additional resources at the end of this lesson. To filter for an exact price, you can use price to underscore price. Time to test it. Visit the menu items endpoint with the filter values you set up and notice the difference. Now the result is properly filtered based on the criteria you passed. Next, let's implement searching. If a client application supplies a search parameter followed by some characters, you will perform a search and return those menu items whose names start with those characters. You do this by adding search equals chocolate at the end of the localhost URL. This should return all menu items starting with chocolate, like chocolate cake and chocolate ice cream. Just like before, get the query string parameter search by typing search at the start and in the parenthesis. To check if there is a value, filter the items with an if statement. This time you will use the starts with field lookup condition. What if you want to search if those characters are present anywhere in the title? You just change the field lookup condition to contains. Lastly, how about making those searches case insensitive? The field lookup condition will be I contains instead of contains. There is also a case insensitive version of starts with, which is I starts with. Now you know how to optimize your API results and perform search and filtering in your DRF projects. You also learned about field lookups, which work as comparison operators during this process. Well done. You already learned how to filter query set in the previous video. This video will demonstrate something else important called ordering or sorting. You will learn how to sort the API result in ascending or descending order based on query string. There is a Django package called Django Filter, which offers advanced filtering, sorting, and searching, but that package is mostly used with class-based views. Since you are using function-based views with API View Decorator, you can take advantage of Django's native sorting methods. After implementation is done, menu items can be sorted using this query string with the menu items endpoint ordering equals price, or with the same endpoint use ordering equals price, inventory. Let's open the menu items function. You need to accept a new query string parameter called ordering. Add this line just after the search. Ordering equals request.query underscore params.get open bracket single quotation mark ordering single quotation mark closed bracket. Now, just before the line where you created the serialized items, add these lines. With this line, you are sorting the query set by the value supplied with the ordering query string. Now visit the menu items endpoint with ordering set to price. What do you notice? The menu items are now properly sorted by price in ascending fashion, which means the items with lower prices go at the top. How can you change the sorting order from ascending to descending so that the item with the highest price goes at the top? Do you need to make any changes to the code? Surprisingly, no code change is required. Just visit the menu items with ordering set to -price, and you will notice the expected result in the browsable API view. Now you learned how to implement sorting or ordering for your API results with just a few lines of code. But there is still room for improvement. What if the client wants to sort the result by two fields, price and inventory? Just like this, you use your normal endpoint, but at the end it reads menu items, ordering equals price, inventory. This way, items will be sorted by price first and then by inventory in ascending fashion. This means that if two menu items have the same price but different inventory values, the one with the lower value will go at the top. How can you do this? You need to split the ordering field with a comma and then call the order by method with that list. You don't need any for loop for this. Remove this line you added just before the serialized items and split the value of the ordering query string by a comma with this line, ordering underscore fields equals ordering dot split, open bracket, double quotation mark, comma, double quotation mark, closed bracket. Now, you can call order by on the items query set for all those fields in the ordering fields array with this line, passing the list as arguments. That's it. You're done. Let's visit the menu items endpoint with a query string like this, ordering equals price, inventory. The result is sorted exactly as it should be. What if you want to sort by price in ascending order and then by inventory in descending order? Simply pass this query string to the menu items endpoint, ordering equals price, inventory. Notice specifically the minus sign before inventory. And the result changes as expected. Now you learned how to sort the result of your API by multiple fields in both ascending and descending order. In this video, you learned how to sort the query set using Django's built-in order by method in ascending and descending order. You also learned how to accept multiple fields in the query string and sort according to them. And finally, you learned about the Django filter class, which is powerful but mainly works with class-based views. By now, you know it's good practice to enable APIs to send results in smaller chunks. Imagine a database with 1,000 orders and the client visits the orders endpoint. If there is no pagination, the client will get 1,000 orders every time when they actually only need the latest 10 orders. This unnecessary operation will put a huge load on the database server and waste the bandwidth. Developers use pagination to chunk results. Client applications can then decide the page number and how many records they want per page. Pagination is an essential technique that you need to learn to save server resources by serving a limited number of records. This video will demonstrate how to implement pagination in your DRF API project. For instance, if the client requests the 7th and 8th menu item, they can make a HTTP GET request using the normal endpoint. But after API comes /menu items, per page equals 2, ampersand page equals 4. The first page contains records 1 and 2. The second page will have records 3 and 4. The third page will display records 5 and 6, and the fourth page will present you with 7 and 8. But here is a useful tip. You should limit the maximum number of records a client can request per page. This is a security measure to prevent abuse of your API endpoints. If you set the maximum limit to 10 records per page from an API endpoint, but the client needs 20 records ranging from 31 to 40, then the client needs to make 2 calls to this API. The first API call will request 10 per page from page 3, which will serve records 21 to 30. The second call will serve the next 10 records, which are 31 to 40 from page 4. But say if a client requests 50 records in one single API call when the maximum limit is 10, you can send a 400 bad request HTTP status message. Let's implement pagination in your Little Lemon app. Open the views.py file and go to the menu items function. You will accept 2 query string parameters, per page and page. Just after the ordering variable, write these 2 lines of code. If the client doesn't supply any value, the per page and pages value will be 2 and 1 respectively. Import paginator and empty page from django.core.paginator. Now just before the serialized items, add this code which will initialize the paginator object. It means you are creating a paginator where the number of items per page equals per page. Now the items from a page can be retrieved using items equals paginator.page, open bracket, number equals page, closed bracket. But a client may request a page that doesn't exist, which will generate an empty page error. This is why you need to wrap this line inside a try-catch block. If the page exists, it will return the items from that page. Otherwise, it will be an empty array. Now visit the menu items endpoint with no query string. There are 2 menu items per page. Excellent, your paginator is working perfectly. Now call the menu items endpoint with the necessary query strings. Set the value of per page equals 3 and page equals 1. Now there are 3 menu items. And that's it. You have successfully implemented pagination for your API project. In this video, you learned the necessity of pagination in an API project. You also learned how to implement pagination using the core paginator module of Django and how to deal with a non-existing page. Good job. Imagine the Little Lemon restaurant featured on a prominent food blog. The positive reviews got people so excited that the visitors on the Little Lemon website increased tremendously. The app downloads also peaked. While this is good news, it will take no time to turn into a nightmare if your app and website can't handle this traffic. In such a scenario, your database would stop responding and your web server will go down. You need to implement a few techniques to ensure nothing goes wrong, and caching is one of those. Earlier in this course, you learned that one of the constraints of REST APIs is that they should be cacheable. Remember, caching is a technique of serving saved results instead of creating a fresh one every time it is requested. And this reduces the server load and bandwidth consumption to a great extent. By now, you also know that REST API is a layered architecture. The interesting thing is that the caching can happen in multiple layers. Let's explore a typical HTTP request flow in a layered API infrastructure. A visitor sends a request to your domain, which goes to the firewall first. From there, it goes to a reverse proxy server that sits in front of your web server. The reverse proxy server transfers the call to one of your web servers. Then the web server connects to the database servers. The database server prepares the response and sends it back to the reverse proxy, which finally sends it back to the visitor who made that request. Now, the caching can be done in the client, reverse proxy, web server, and database server. Let's examine the role of each of these layers in caching, starting with the last layer, the database server. Most modern databases do caching to prevent excessive read-write operation in the actual storage. Typically, they use query cache, where the SQL queries and their result are stored in the memory. If there is no change in any of those fields in that SQL, they serve the result from the memory instead of preparing the result by running that query against the real data. This can save a huge amount of processing power and time. However, relying only on database caching is a bad idea, because your server-side scripts are still connecting to the database to get a cached result, and for a given amount of RAM and CPU, database engines can only accept a fixed number of connections at a time. Next up, caching on the web server. The web server runs the server-side scripts which can cache the response if it is certain that there was no change in the data since the last time it was queried or accessed. Server-side scripts cache the result in a separate cache storage, which could be simple files or a database, or in caching tools like Redis or Memcached, which can save you from connecting to the database every time. Just imagine you have 1,000 hits every minute, and you update the data once every day. There is simply no reason to connect the database thousands of times every minute. Instead, you hit the database one time and cache the result, and then serve the 1,000 times 60 times 24 requests straight from the cache every day. That's 1,440,000 requests. When the database is updated, you flush the old cache and then cache the new result to keep going on. Just imagine how much processing time and computing power you are saving this way. But even the web servers have limited capacity to respond to a number of active requests at a time. And that's where reverse proxy caching comes in. Traffic-heavy applications use multiple web servers behind reverse proxies to distribute the requests evenly. The web server can send responses with appropriate caching headers, and the reverse proxy then caches the result for a certain amount of time, as mentioned in those headers. They then serve the request straight from the cache. This way, your web servers will not get clogged with too many requests. Finally, there is client-side caching. Reverse proxies or web servers can send responses with caching headers which tell the client to cache the request for a specific time. During this time, if a request is made, the client browser or application decides whether it will use those caching headers, serve the result from a local cache, or create a call to your server. Since this is a client-side behavior where you may not have complete control, it's always a good idea to implement the proper caching strategy on the server side. Caching is good. It can save a lot of resources when you implement it properly. And in this video, you learned about the different ways you can implement caching in your infrastructure. Previously, you learned that APIs are the gateway to your back-end data. By using APIs, third parties can access your data, which poses the risk of data breaches or corruption. Some APIs are meant to be used by anyone, and some APIs, especially those that modify data, are meant to be accessed only by authenticated clients. In this video, you will learn how to implement authentication in DRF and then protect your API endpoints from public access. Previously, you learned that in password-based authentication, the client or the API user sends their username and password with every API call. Then you can verify these credentials and deliver the appropriate response. However, sending a username and password every time is frustrating, and it is also not secure. That's why token-based authentication is the most popular method when it comes to API authentication. In this approach, users send their usernames and passwords once. If the credentials are okayed, the server generates a unique piece of string. This token is long, hard to read, and contains alphanumerical characters and symbols. The server can decide for how long a token will be valid and when it expires. The client sends new API requests and includes this token in the header. Server-side scripts then check if the token is valid or if it has expired. Then it finds which user this token belongs to. This token is validated with the help of Token Authentication class in the Auth Token app provided by DRF. If everything is okay, the API will run on behalf of that user. The authentication process is now done using the token, and you avoid sending the username and password every time. Let's explore a practical example of how to implement token-based authentication in DRF. Open settings.py and add rest_framework.authToken in your installed app section. Now open your terminal and go to the project directory. Make sure you have the virtual environment active using pipenv shell. Run the necessary migrations from the auth token app. Right, now let's create an admin user to access the Django admin panel using the command python manage.py create super user, and then supply the username and password. Access the admin panel from the localhost URL /admin and log in as the admin or super user you just created. All previously created tokens for all users are displayed here. You can also create tokens for new users here. Click on the plus or add button and create the token. You can come back to the tokens section and check these tokens anytime. But now it's time to create a protected API endpoint. Open the views.py file and add the following code: @API_view def secret request. For the return, add the response message some secret message and map it to the /API/secret endpoint. Now any client can access this endpoint. Not secret and not secure at all. Let's protect it so that only token-verified users can access it. Import the isAuthenticated class from permissions and the permission_ classes decorator from the decorators module in D or F. Now it's time to add some magic to our secret method. Add the permission classes decorator. This code snippet will return a secret message for the authenticated users only. Next, let's visit the API secret endpoint in Insomnia to test how it works. Great. Currently, you are not authenticated, so DRF doesn't allow you to pass. It shows authentication credentials were not provided. So the API endpoint is now secure. You need to tell DRF to use the token-based authentication. Simply set token authentication as the default authentication class in the settings.py file, and these lines in the REST framework section. Now go back to the Django admin and copy the token. Come back to Insomnia and click on the Auth tab next to Body and select Bearer Token. Paste the token you just copied in the token field and write token in the prefix field. Authentication tokens are sent as authorization, token, space, the actual token in the header. And this is what you just did using Insomnia. Send the request. And that's it. The secret message is there. Token authentication now works. You can create another user from the Django admin panel and use that user's token. But how can you generate these tokens from an API endpoint? Don't worry, DRF has everything ready for you. Open the Little Lemon app urls.py file and import the obtain_auth_token class from the rest_framework.authtoken.views module, and add this URL pattern for token generation. This endpoint only accepts HTTP post calls. Send a post call to this endpoint /API token auth. DRF tells you that you need to supply the username and password. Add the username and password of a user that you created from Django admin in Insomnia as form URL encoded data and send the post request again. If the credentials are valid, DRF sends the user token in a response. If you create a new user from the Django admin panel or via code, you can always use the endpoint /API/API token auth to authenticate them and generate a token. Then use this token to make HTTP calls to the protected URLs. In this video, you learned about password and token-based authentication in DRF. You should now know how to protect an API endpoint by using the built-in decorators and classes. And you also learned how to generate user tokens to authenticate API calls. Back-end developers should always try to optimize the security of their systems. This knowledge will serve you well in your future API projects. You have already learned how to protect API endpoints by using token-based authentication and permission classes in DRF. But even after proper authentication, there could be some issues. What if an authenticated user makes a HTTP delete call to one of the menu items? Or what if an authenticated customer submits a HTTP patch request to an order item and changes the data? Relying only on the authentication check will not be sufficient to protect your data. You must also check privileges, like if the authenticated user has authorization to perform this action. This video will demonstrate how to take advantage of Django's built-in user group system and create a solid authorization layer for your APIs. Open the Django admin panel from the localhost URL /admin/ and log in as the super user. Let's create some groups. Click on the Add button beside Groups. It will take you to a new screen. Type the name Manager and click on the Save button. No need to select the permissions for this role. Now create two users from the Users section. One is John Doe, who will be our manager, and the other user, Jimmy Doe, who will be the customer. Go back to the Users section. You'll note these two users. Click on John Doe and add his first name, last name, and an email address you can create for him. Scroll down until you see the Groups section. Click on Manager and then click on the right arrow button next to this box. After you click, the Manager group will go to the right box. It means that the Manager group has been assigned to the user John Doe. Save it. Excellent. You have created the foundation of your authorization layer. Let's go back to the coding to make this work. Open the views.py file and create a new method called ManagerView. Just like the secret method you created earlier, add the API view and permission classes decorator, and map this method in the urls.py file. Let's log in as John Doe and create a token. Like you learned earlier, send a HTTP post call to the API token auth endpoint with John Doe's username and password. You will get the token in return. Save it somewhere for now. Similarly, get the token for Jimmy Doe and save it for later use. Now send a GET request to the Manager View endpoint with John Doe's token. Nice. It displays the message, "Only manager should see this." But what if you send another request to this endpoint with Jimmy Doe's token? DRF still shows the message that only managers are supposed to see it. Let's fix it. Go back to the views.py file to the Manager View method. You need to check if the currently authenticated user belongs to the manager group. If yes, then display the message. Otherwise, send an error with a 403 status code. Rewrite the method manager view to check if the currently authenticated user belongs to some group. Using this line, the API developer can check which groups the current authenticated user belongs to, and then check if the manager group exists in that list. If exists returns true, it means that the current user belongs to the manager group. Now send the HTTP GET request to the Manager View endpoint with John Doe's token. What message comes up? DRF displays this message because John Doe is in the manager group. Send another call with Jimmy Doe's token. This time you see the error. Nice, your authorization layer is working perfectly. In this way, you can protect any API endpoint from unauthorized access in DRF. In this video, you learned a very important lesson, how to protect your API endpoints from unauthorized access by implementing an authorization layer using Django's user groups. You also learned how to create users, groups, and assign these groups to a user. Throttling is a very efficient technique to prevent API abuse. Computing power and bandwidth are involved with every request, and if you don't monitor it, your API infrastructure will be at risk. With throttling, you can control how often APIs can be accessed in a certain amount of time, and in this video, you will learn how to do that. Throttling classes are built into DRF. There are two major types of throttling. One is for anonymous or unauthenticated users, and the second one is for authenticated users. An anonymous throttling rate will be used when there is no token in the API header, and user throttling will be used when there are valid tokens. What if you want another policy for some API endpoints so that the authenticated users can call them 10 times per minute? Let's do that. Start by creating a new function at the views.py file called throttlecheck. When someone accesses this endpoint, it will simply display a message saying successful, and map this function so that it can be accessed as /API/throttlecheck. Now you will limit this endpoint for anonymous users to 2 calls per minute. Import the anon_rate_throttle class from the REST framework throttling module. Also, import the throttle class's decorator function from the REST framework decorators module. Then in the views.py file, add a throttle class decorator and pass the anon_rate_throttle to it. After the @API view decorator for the throttle check function, @throttle_classes, open parentheses, square brace, anon_rate_throttle, close square brace, close parentheses. This line instructs DRF to use the anonymous throttling policy for this function. Open the settings.py file and add a new section called Default Throttle Rates in the REST Framework section. Then type anon:2/minute. Instead of using minute, you can also use second, hour, or day. Now visit this endpoint API /throttlecheck and notice the message. Then refresh the endpoint 2 more times. Notice that this time DRF blocks the call and displays a message saying detail request was throttled, expected available in 59 seconds. After 59 seconds, you can make 2 calls to this endpoint again, and you can do this every minute. That was straightforward, right? So, what do you think will the throttling setting be if you want to throttle an endpoint for anonymous users to 20 calls per day? Yes, it will be anon:20/day. And how can you throttle some endpoints for the authenticated users to 10 calls per minute? To do this, import the user rate throttle class from the REST framework throttling module. Then, create a new function only for authenticated users. This time, use user rate throttle as a throttling class, and map this function so that it can be accessed as API/throttlecheck_auth. Finally, add this line in the settings.py file just after that anon-throttle setting, user:5/minute. Now, using Insomnia, send a HTTP GET call with a valid user token to this endpoint. After 5 successful calls, DRF will display the same message to you that you saw earlier when the throttle limit was reached. Excellent. Everything is working just fine, but let's explore one more example. With the current settings, when you use throttling classes, all API endpoints will be limited to 2 calls per minute for anonymous users and 5 calls per minute for authenticated users. But say you want another policy for some API endpoints so that authenticated users can call them 10 times per minute. Let's do that. Create a new file called throttles.py in your apps directory and add the following code: class 10 calls per minute, user rate throttle, and then scope equals 10. This code creates a new throttle policy with a named scope. This scope will be used in the settings.py file to establish the throttling, or 10 calls per minute. Now open the settings.py file and add this line of code after the user setting in the default throttle rate section: 10:10/minute. Now import this 10 calls per minute class in your views.py file and use this class as a throttle class for any authenticated function calls. That's it. Now authenticated users can access this endpoint 10 times per minute, and DRF will block any extra calls. Let's test it in Insomnia. Here I am making 10 calls to this endpoint, API/throttlecheck_auth, but it blocks me on my 11th call. In this video, you learned how to prevent abuse of your API endpoints by implementing rate limiting or throttling using DRF's classes. You also learned how to change the settings for anonymous and authenticated users, and allow some APIs to be called by a custom rate using throttling scopes. Authentication and authorization are two of the most crucial parts of every application. If done wrong, it can lead to data breaches or data corruption. Knowing how the authentication system works in Django and DRF is essential. But it can be tedious and time-consuming to do everything from scratch every time. Wouldn't it be much better if you could use a simple authentication library, configure it with just a few lines of code, and get a fully functional authentication layer for your DRF project? And that's what Djoser enables you to do. In this video, you will learn about Djoser, an easy-to-use authentication package for DRF. Let's start with installing the Djoser package in your project using pipenv. Make sure that you have activated your virtual environment using pipenv shell first. Now run the command pipenv install Djoser. This will install Djoser in your project, but you are not done yet. You need to configure a few things first. Open your settings.py file and add the Djoser app in the Installed App section. Remember, it's important that you keep Djoser after the REST_framework app. Create a new section called Djoser and add user ID field and username to it. This is how you specify which field in your user model will act as the primary key. Sometimes, people prefer to use the email address as the username, which you can change using the login_ field option. Let's go with the default settings for now. Remember, you added the token authentication class in the default authentication classes section in the REST framework earlier in this course. If you want to use the Django admin login simultaneously with the browsable API view of Djoser, you need to add this session authentication class too. Don't worry, you can remove it later at any time before going to production. Now, in your main urls.py file, you need to enable Djoser endpoints. Open this file and add these two lines in the URL pattern section. Djoser offers a few handy endpoints. Here is a list of them. Some of them support only the get method, and some of them support post, put, patch, and delete methods. You can access these endpoints by adding http://127.0.0.1:8000/auth in front of each one of them. You can access these endpoints by adding them to the end of the localhost URL. If you visit the auth users endpoint and want to add new users, then you need to log in as a super user in the Django admin first. Then you can visit these browsable API endpoints. There is a new button called Extra Actions added beside the Options and Get button in the browsable API view. Click on that to quickly perform the common operations related to the endpoint that you are visiting. Click on the Options button while visiting any of these endpoints in the browsable API view, and you'll note useful information like what parameters or HTTP methods these endpoints accept. Let me guide you through some of these endpoints. The users endpoint lists all the users, and you can make a post call to create a new one. If you want to create a new user from an API client like Insomnia, you don't need to pass any token to this API. You can also create tokens for a user from the auth token login endpoint. You can use Insomnia to make a HTTP post call with username and password and receive the token. Or you can use the browsable API view. There is a form with username and password fields that you can use to generate user tokens. And the final one is the auth users me endpoint. Make a get call with any user's token to this endpoint, and it will provide the details of the authenticated user. This endpoint also supports a put call to update the email address of this user. With this Djoser library and a few lines of configuration, you get some handy API endpoints to deal with users and token-based authentication in your DRF project. Djoser library also offers a different type of token-based authentication, which is called JSON Web Token, or JWT, and you will learn about it later in this course. In this video, you learned about an authentication package called Djoser. You learned how to install Djoser and configure it correctly in your DRF API project to deal with users and token-based authentication. You also learned about the handy endpoints and their functions offered by the Djoser library. Like the built-in token system in DRF, you can also use JSON Web Token or JWT, a popular token system for API authentication. In this video, you will learn how to implement JWT in your DRF API project. To implement JWT-based authentication for your API endpoints, you need the Django REST framework simple JWT package. Activate the virtual environment of your project using pipenv shell. Now run the command pipenv install Django REST framework simple JWT == 5.2.1. Go to your settings.py file and add REST framework simple JWT in the installed app section. Next, go to the default authentication classes in the REST framework section in your settings.py file and add the JWT authentication class to this list. Then import some essential classes from the REST framework simple JWT fuse module. The simple JWT package needs some API endpoints so that it can accept the username and password and generate the JWT token. To enable those endpoints, open the main urls.py file and add these two lines in the URL patterns array. Essentially, token obtain pair view generates the token. That's it. Your project is now ready for JWT authentication. It's time to move over to Insomnia to create a JWT token. You do this by sending the username and password in a HTTP post call to the endpoint API /token. 2 tokens are returned as a response. Keep a note of these 2 tokens so you can use them later in the process. There are 2 essential tokens involved in JWT. One is an access token, which the client will use to authenticate the API calls. This access token expires after 5 minutes in simple JWT. And the other is the refresh token to regenerate the access token. Refresh tokens will be discussed a bit later in this video. You can specify the period after which the access token expires in the settings.py file, but it's always a good idea to keep this expiry period short. When this access token expires, the API calls can no longer authenticate with this access token. But that doesn't mean that the client needs to log in again. They can use the refresh token from the previous call to regenerate an access token again. And then you can use this regenerated access token to authenticate an API call again. This is a security measure involved with JWT, and it's important because you cannot manually let an access token expire. So, if you need to prevent someone from regenerating the access token, you can blacklist the refresh token so that it cannot be used anymore. But more on this later. Let's copy this access token. In Insomnia, create a new HTTP request to the endpoint API /secret. An isAuthenticated class already protects this endpoint. Next, click on the Auth tab in Insomnia and select Bearer. Paste this access token in the token field and send the request. Now the secret message displays. JWT authentication is working perfectly. Wait for 5 minutes and just hit the send button again. DRF is telling you that this access token has expired and is no longer valid. Let's regenerate the access token using the refresh token. Create another HTTP post call in Insomnia. This time, the endpoint should be API /token /refresh. Click on the body tab and select Form URL encoded. Type refresh as the key and paste the previously saved refresh token as value. Hit the send button. A new access token has been generated. The client can now use this access token to make authenticated API calls again. Finally, let's explore how to blacklist a token. Remember, you cannot manually let a JWT access token expire, so if you need to block a client from generating JWT access tokens, you can do this using utility blacklisting app provided by the simple JWT package. This app will be used to blacklist the refresh token so that it cannot generate an access token anymore. First, add this line of code in the installed app section in the settings.py file. REST framework _simplejwt.token_blacklist. To use this token blacklist app, you need to run some migrations. So, stop the web server and run this command in the terminal. Python manage.pymigrate. After the migration is done, rerun the web server again. Now go to the main urls.py file and import the token black last view class from the REST framework simplejwt.views module, and add some code to the URL patterns path to enable this token blacklist API endpoint. Now create a new HTTP post request to the endpoint API/token/blacklist. Then click on the body tab and add refresh as the key and the previous refresh token as value. Hit the send button. DRF will return an empty response, but that's okay. Now this refresh token has been blacklisted. Next, try to regenerate the access token with this blacklisted refresh token. What happens? DRF now tells you that you cannot use this refresh token because it is blacklisted. That's everything you need to know about using JWT tokens for API authentication in your DRF projects. You learned about JSON Web Token or JWT in this video and how to use JWT tokens to authenticate API calls. You also learned how to regenerate access tokens using a refresh token and blacklist a refresh token if needed. With this knowledge, you are one step closer to creating secure APIs. Well done. So far, you have learned about built-in token-based authentication in DRF, Djoser, JWT, and many more. In this video, you will learn how to register new users using these API endpoints. And you will also create a new API for super admin only, which will be used to assign users to groups or to remove them. You will not be using JWT in this video, so it's best to clean up JWT-specific settings and URL patterns from settings.py and urls.py. Let's start with the user registration system. This can be a little complex with the plain DRF, but wait, you have included Djoser, and the library will make things easier for you. Djoser has introduced a few URLs, but you are only interested in auth user's endpoint. If you log in as a super user in the Django admin and then browse this endpoint, all the users will be visible to you, but other people cannot browse this endpoint without a valid token. And if they make a HTTP GET call to this endpoint with their token, only their username and email will be visible to them. But with a super admin token, they're all available to you. This endpoint can accept public HTTP post calls with email, username, and password without any token. The user will be created if the username is not taken. Open Insomnia and create a HTTP post request to this auth user's endpoint. Click on the Body tab, select Form URL Encoded, and add 3 post fields named username, email, and password. Click the Send button, and DRF sends a 201 created response with the new username and email address. So, your user registration endpoint is fully functioning without any changes to your code at all. You need a particular endpoint for the super admin, which will be used to assign a user to the manager group or remove them from it. Open the views.py file and create a new function called managers with the API view and permission class as decorator. This endpoint can only be accessed with a super admin token, so you need a special type of permission called isAdminUser. Import it from rest_framework.permissions import isAdminUser, and add this isAdminUser class to the permission class as decorator. Now map this function in the Little Lemon API /urls.py file to the URL patterns array. Test this endpoint with a normal user token and super admin token. Add /API/groups /manager/users to the end of the localhost URL. For a normal user token, you'll note the error, and when you call it with a super user token, you will note that DRF displays message OK. This endpoint should accept one post field, the username. If the username is present, find the user and add it to the group. For this, you must import the user and group class like this. From django.contrib.auth.models import user group. Now add some code in your function. If the username is present in the HTTP post call, you will find the user with the get_object_ or _404 method. Then find the manager group and add this user to that group. Otherwise, return an error with the 400 status code. Now open Insomnia and make a post call to this endpoint with the username. Use a super admin token for this call. If everything is fine, an OK message will display. Check what happens if you call this method with a user token. You also need to add support for delete calls to remove a user from this endpoint. You can do it with slight changes to your code. Let's modify the managers function like this. After checking if the client supplied the username, you should check the method type. If the method type is post, add this user to the group. If the method type is delete, remove the user from the group. So now you have a fully functional API endpoint for the super admin to add and remove users from the groups. In this video, you learned how to register new users using the Djoser package and how to enable the super admin to add users to a group or remove them from one. You've reached the end of another week. Well done. Let's take a quick tour of what you covered in this section of the course about searching, ordering, and filtering data, and also how to control access to your APIs. In the first lesson, you were introduced to the concepts of filtering, ordering, searching, and paginating. This included learning why filtering is important and how it is usually performed by passing query strings. And you learned how to order API results in both ascending and descending order, as well as how to perform multiple ordering. You learned about data sanitization and why it is important from a security perspective, because unsanitized data can cause vulnerabilities. Next, you learned how to paginate your restaurant menu items by specifying how many items you want per page. And then you got the results for a specific page by providing a page number to the API. Pagination helps the server to perform better by consuming less resources. After this, you learned about the benefits of caching in an API project and how it can help overall performance. And you learned how to cache an API result in DRF. In the first lesson's ungraded lab, you implemented what you learned in your own project by adding a category type and adding it to your menu items, filtering foods by category, ordering food by price in a specific category, and paginating the menu items. In the second lesson, you learned all about securing an API in Django REST framework. Therefore, you learned more about token-based authentication in DRF by creating a simple registration and login API that uses the generated tokens to authenticate API calls. And when it comes to security, user roles are pretty important, which is why you learned how to create different types of user roles in DRF. You also learned how to set up API throttling and learned what its advantages are. Next, you learned about Djoser library and what the benefits are of using this library over DRF's built-in authentication system. You also learned about new authentication endpoints introduced by Djoser library for the registration and sign-in process, as well as how to add Djosers to your existing project. Finally, you used the knowledge you gained about Djosers to create a food rating API with throttling. Overall, after completing this week, you should be able to implement searching, filtering, ordering, and pagination to optimize the output of your APIs, explain how caching works on different layers in an API architecture, use built-in token-based authentication in DRF, create user roles, and implement throttling to control access to your APIs. And lastly, you should know how to use JSON Web Tokens to protect your API endpoints. Only one more week to go before you've completed the course. Good luck. You've made it to the end of the course. Why don't you take a moment to congratulate yourself? After all, you've learned a lot in this course. Let's recap. In the very first week, you learned how APIs are used in the real world. Next up was a quick refresher all about HTTP and HTTPS, in which you covered HTTP methods, requests, responses, and status codes. You also learned how to set up Visual Studio Code and how to use API clients like Insomnia and tools like pipenv. After that, you learned about REST API's best practices, key characteristics, and benefits, and the API request lifecycle. You then learned about access control and the difference between authentication and authorization. Authentication gives you access, while authorization allows you to perform certain actions. Following this, you created your own API and learned how to organize an API project by creating routes and using correct naming conventions. And you learned how to debug Python scripts from VS Code using the built-in debugging tools, as well as how to create mock APIs to develop your applications. You then learned how to install and set up Django REST Framework, or DRF, as well as how to create a basic API using DRF. You discovered how DRF can retrieve data from a database, process it, and then present it as JSON, XML, or other formats to your clients. Now that was important. And you learned more about the API view decorator and its benefits, as well as how to use function and class-based views to create API endpoints. Next, you learned more about the different types of serializers and how you can use them to convert and validate your data. In this section of the course, you also learned how to use the built-in renderers in DRF to display API output in different formats. And in the third week, you learned about access control and API maintenance, as well as the concepts of filtering, ordering, searching, and paginating. You also covered how to cache an API result in DRF, as well as how to test and secure an API in DRF. Lastly, you learned more about token-based authentication in DRF and how to create user roles to ensure good security, and how to use the Djoser library for the registration and sign-in process. Now you're ready to tackle the graded assessment, the Little Lemon Restaurant API project. Good luck. Congratulations on making it this far. You learned all the basics of REST API development, the good, the bad, the do's and the don'ts, and finally, you are here to use that knowledge to build an API project for the Little Lemon Restaurant. This will be fun and a little challenging at the same time. Let's dive into a demonstration of what you are going to do. In this project, you will deal with 3 types of users: managers, customers, and the delivery crew. You can use the knowledge of user roles you learned earlier in this course. You will start with the user registration and authentication process that each user will use. Then you will create API endpoints that can be used to assign users to a group, like manager or a delivery person. This endpoint can be used to remove them from the groups too. You will need to think carefully about what type of token is required for this endpoint. Now, first is the manager role. Only managers can use some API endpoints to add, edit, and remove menu items. Managers should also be able to update any user to a delivery person. Next up is the customer role. If a user doesn't belong to any specific group, you should consider them a customer. Customers should be able to browse menu items, filter them by categories and price ranges, and search menu items. You need to create APIs that will allow customers to add menu items to their cart and place an order. But here's the catch. The cart must be emptied when the order is successfully created. Does this sound a little bit tricky? Don't worry, you can do it. You can also add an API endpoint to flush the cart at any point. One customer should only be able to have one cart at a time, and one cart should be able to contain multiple menu items. Last, there are APIs related to the delivery process. First, you need API endpoints for the managers to browse the orders and assign them to a delivery person. Managers should also be able to filter orders by their status, like delivered and not delivered. After successful authentication, Delivery people should be able to browse orders assigned to them by using your API endpoints and mark them as delivered. And customers can always come to the orders endpoint to see their orders, including the status of that order and the total price. And finally, you will need to implement some throttling for the APIs you built. Limit it to 5 API calls per minute. While working on this project, please ensure that your API endpoints support only the required HTTP methods, and always return the appropriate status code with the response. Let's discuss the tools you'll need. You should use VS Code for writing the code. You will need to use Django with Django REST Framework or DRF, and everything should work in a virtual environment. For testing and debugging, you can use Insomnia. Use only the packages and libraries you learned about earlier in this course. Just one last thing. If you use a session authentication class during the development, make sure to comment that out before submission. The finished project should only support token-based authentication. It's time to implement the knowledge you gained in this video. Good luck. Now that you know the scope of this project and you've read about database schema, it's time to create the models for this final project. Let's start. You need a few models to implement all the features in your project. Django already comes with the user model, so you don't need to worry about that. Now open the models.py file and start with the category model. This model only requires 2 fields, a slug and a title. For the slug, you will use the slug field type. The title will be char field with a maximum length of 255. The client application will search against this title field, so you must index it. Next, a menu item model is required. A menu item can have a title and price, which will be char field and decimal field respectively. It also needs a Boolean field that indicates if this menu item is set as featured. And finally, a menu item will always belong to a category, so you need a category field as a foreign key. Now, let's start with the cart model. A cart model is a temporary storage for users who can add menu items before placing an order. Remember in the project scope, it was mentioned that a user can only have one cart at a time? This model needs a user field which will be a foreign key to the user model. You need to import this model from the django.contrib.auth.models module. The cart model also needs a menu item field, which will be a foreign key to the menu item model. And finally, you need a quantity field and 2 price fields for easier calculation. One is the unit price of the menu item, and the other is the price, which multiplies the quantity with the unit price and saves the result. When someone places the order, 2 things will happen. An order will be created that holds some important information about this order. So, where will the menu items related to that order go from the cart? As soon as the order is placed, all the items will move from the cart to an order item table and link those menu items with the order ID. Let's create these 2 models. The order model needs a user field, linking to the user's table as a foreign key, and a Boolean field called status to mark if the order is delivered or not. The default value of this field will be set to 0. Then there's a total field containing the price of all the menu items in this order, and a date field to mark when this order was placed. In this model, you will need another field called a delivery crew, which will link to the user model. In Django, you cannot create 2 foreign keys referring to the same field in a foreign table. You must set a related name for it. So the related name of this field was set to delivery_crew, because both user and delivery crew were referencing the user ID in the user table. And here comes the last model, the order item. All the items from the cart will be moved here with a link to the newly created order ID, and then those cart items will be deleted. So after placing the order, the cart will be empty and your user can start adding new items for a new order. You need a foreign key order referencing the order model in this model. Then comes the menu item, again another foreign key for the menu item model. You also need a quantity field because someone can add multiple items for a menu item. Just like the cart model, this model also requires a unit price and price field for easier calculation. Note the use of two metaclasses in the cart and order item model for two unique indexes. In the cart model, this line means that there can be only one menu item entry for a specific user. You can only change the quantity of that menu item. And in the order item model, this unique index means that one order can have only one entry for a specific menu item, but the quantity can vary. Now that you have your models ready, it's time to start writing code. Congratulations on reaching the end of this APIs course in the Backend Developer Program. This course allowed you to delve deeper into the process and concepts behind APIs and their infrastructure. You've worked hard to get here, learned a lot, and developed a lot of new skills during the course. You were able to demonstrate some of this learning and your practical API development skill set by creating your own booklist API project, as well as a Little Lemon Restaurant API project. In addition to this, following your completion of this course, you should now be able to understand RESTful API development, use the Django REST framework to create APIs efficiently, serialize database models, convert and validate data, implement search, ordering, filtering, and pagination, and control access to your APIs and put systems in place to ensure you maintain their health. So what are the next steps? Well, this is the 6th course in the Backend Developer Program, and you have gained a valuable understanding of important concepts and practical skills. You probably realize that there's still more for you to learn. If you found this course helpful and want to discover more, then why not register for the next course on full stack development? In this course, you will practice bringing together multiple skills to build a full stack Django app. Throughout each of the courses in the program, you'll continue to expand your skill set. And in the final assessment, you'll bring together all the skills you've learned to manage your own project. Once you've successfully completed all the courses in this Backend Developer Program, you'll receive a certificate. Certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. You've done a great job so far, and you should be proud of your progress. The experience you gained so far will show potential employers that you are motivated, capable, and not afraid to learn new things. Again, congratulations on finishing this course, and good luck with the rest of your educational journey.